Hey everyone, welcome to this new video on Six Sigma Crash Course by Simplilearn. Before we begin, consider subscribing to our channel and hit the bell icon to never miss any updates from Simplilearn. In this video, we will start by knowing what is Six Sigma, what are the benefits of Six Sigma. Moving ahead, we will understand the major difference between Six Sigma and Lean Six Sigma. We will dive deeper into the Six Sigma Green Belt training, followed by some Six Sigma tools. By the end of this video, we will see some important Six Sigma interview questions needed to ace in Six Sigma interviews. To make your journey more successful in Six Sigma, we introduce you Lean Six Sigma Green Belt Certification Training course by Simplilearn. This Green Belt training offers 35 PDUs for simulation test papers, for real-life projects, and courses aligned with IASSC. You will gain important skills like project management, measurement system analysis, data analysis, lean principle, process analysis, and more. Become an expert. Grab the course now. Find the course link in the description box. Listen to what our learners say about our courses.
Finishing the course led to personal recognition and opened the door for even more artificial intelligence projects, and it came with a significant pay raise, might I add.
Hi, I'm Philip. I'm 61 years old, and last year I upskilled with Simplilearn's postgraduate program in cybersecurity. I'm happy to tell you that I was able to clear and pass my CISSP and CCSP certification exams on the first attempt after taking the course.
We decided to take a course in DevOps from Simplilearn.
The course proved to be very beneficial for both our careers.
Yeah, I got a promotion after the course.
And I got hired with a new company.
At first, I tried to learn from YouTube and then apply for a few jobs. But I couldn't crack any. Then one of my friends suggested I go for a certification course with Simplilearn. My overall experience with Simplilearn was very good. Within a few days, I got 3 callbacks. 2 were project management positions and 1 was in data science field.
I successfully changed my career from software development to digital marketing, and Simplilearn presented the perfect route. I chose Simplilearn because of its tremendously high rating. To be rated as one of the best education portals online worldwide is surely promising. I switched to a new role as a digital marketing manager. With this, my skill upgraded, my salary increased, and my self-confidence boosted alongside numerous other positive outcomes.
So without any further ado, let's begin. Over to our experts.
Six Sigma is a set of tools and techniques that have helped several companies around the world achieve business success. Hi guys, I'm Rahul from Simplilearn, and let's get started with our introduction to Six Sigma. Now let's understand this better with an example. Here let's talk about how things were before Six Sigma was introduced. Here Jenny and James are having a conversation with each other. Jenny is James's manager and she's not happy at all. She says James is in a lot of trouble. This is because she found out that the customers weren't happy with the organization's service and the operational costs were way too high. And as manager, James had to make sure that this did not happen. Now let's have a look at the same scenario in present day. Here we have Jenny congratulating James. She's very impressed with his work, but James says it's all thanks to Six Sigma methodology. So Jenny asks, she wants to know more about Six Sigma. So to understand Six Sigma, here's what you need to know. Firstly, we'll have to understand what is Six Sigma, what its advantages are, some of its methodologies, what are the different roles in a Six Sigma team, what is lean, what is a lean process, and what is Lean Six Sigma. So now let's get started with understanding what exactly is Six Sigma. The Six Sigma methodology makes sure to find as well as eliminate any sort of defect or variation that could be affecting your product, service, or process. Now this methodology is statistics based, is data driven, and focused on continuous improvement. Now this means that there's no end goal in the horizon. There's always another goal to reach. There are 3 core ideologies behind Six Sigma. The first one states that for any business to be successful, there's continuous efforts that are required so that you can achieve stable as well as predictable process results. The second ideology states that in any business or manufacturing process, there are certain characteristics that can be defined, measured, analyzed, and controlled. The final ideology says that along with the rest of the organization, the top level management plays a very important role to making sure that there's sustained quality. Now let's talk about the advantages of Six Sigma. Six Sigma can help produce a roadmap or a path through which you can easily find and reduce any sort of organizational risk and reduce the operational costs. Another advantage is that it helps improve the efficiency of the process and making sure that it works in a timely manner. It decreases defects, improves the overall tracking and monitoring process, and ensures that the products are aligned with the company's policies. It is also reported that it greatly helps improve customer as well as vendor satisfaction. It helps improve the cash flow and ensures that the products are complying with the regulations of the organization. Now let me tell you about the process of Six Sigma. Now Six Sigma projects are of basically two methodologies, the DMAIC and the DMADV. Now let's talk about DMAIC in detail. That's short for Define, Measure, Analyze, Improve and Control. This is one of the most commonly used methodologies in the world. This is commonly used by companies when they have to fix or improve an already existing product or process that does not meet the company's standards. Now let's have a look at the process. First phase is the define phase. In this phase, you define the problem that the customers are facing, you find out where you can improve, and you clearly understand what the customers require of you. The second phase is the measure phase. Now in this phase, you actually identify how well the process is doing in its current unaltered state. In the analyze phase, you process the data that you get from the measure phase and determine what exactly is the cause of the delay or variation. In the improve phase, you start by making small changes to the business process and make sure that the problem you identified earlier is being taken care of. And finally, in the control phase, you control the new process so that it doesn't go wrong and use the same knowledge for future processes. Now let's have a look at DMADV. This is short for Define, Measure, Analyze, Design and Verify. Now this is also commonly known as DFSS or the Design for Six Sigma. Now this is commonly used by companies around the world when they have a new product that needs to be created all the way from scratch. In the first phase, which is the define phase, you define what the goal of the project is and what the customers require of you. In the measure phase, you measure as well as determine what the customer needs and how they respond to your products. In the analyze phase, you perform analyses to determine how you can improve your product or service so they can better serve your customers. In the design phase, you set up process details and make optimizations to the design to make sure your customer is satisfied. And finally, in the verify phase, you check how well the design is working out and how well it meets the customer's needs. Now before we go on, let's talk about how Six Sigma was used in reference to the earlier example, the situation that James was facing. A survey conducted by the organization James was working for indicated that the customers weren't very happy with the organization. So they decided to fix that with the help of Six Sigma. So they decided that the DMAIC methodology would be best suited to solve their problem. So let's have a look at what they did. Firstly, in the define phase, they used a tool called the voice of the customer. This tool represented the needs as well as requirements of the customer. This showed that the customers expected prompt delivery, the correct product selection, and a knowledgeable distribution team from the company. And now on to the measure phase. The company wanted to know why the customers didn't like them, so they performed some data collection. From there, they found out that they took 56% longer than other companies to deliver their product. So they decided to reduce the amount of time it takes between order entry and the delivery of the product. And now in the analyze phase. Here they knew what the issue was, but they wanted to know what exactly made their product's delivery so slow. Why were the customers receiving the product so late? Then they performed some analysis. Their analysis showed the possible causes. It could have been inaccurate sales plans, issues with their safety stock, issues with their vendors' delivery performance, and falling behind on the manufacturing schedule. Further analysis also indicated that most of their sales, almost 80%, came from 30% of their products. The issue was that they didn't have enough safety stock to satisfy the customers who required that 30% of products. And now onto the improve phase. So now that they knew what was causing their problem, they wanted to solve it. They began to have monthly reviews and tried to make sure that their in-demand products stayed in demand. Another thing that they wanted to focus on was to make sure that they could order and provide the customer with the products that they wanted. And finally, onto the control phase. They began to set up plans so that they could monitor the sales of that 30% of products that were selling the most. Each year, they would review how well a product was selling and replace it if it had fallen out of favor. Now, let me tell you what a Six Sigma team consists of. Let's talk about the roles in a Six Sigma team. First up is level 7. Now, these are individuals who are at the novice level. Now, these individuals don't know in great detail about what the project is, but they have a basic understanding of the principles and the methodology behind the program. Now, they usually support with smaller projects and with smaller issues, but these individuals found the foundation for the people who decide where the program is going. And now we're at level 6. Now, these are individuals who have a yellow belt certification. Now, they are core members of the Six Sigma team who have an understanding of how the basic metrics work and how they can perform some sort of improvement. Now they have their own areas of expertise and they're required to determine certain processes that need to improve. At the same time, they're also in charge of smaller improvement projects. Now, level 5. These are people who have a green belt certification. Now these individuals are usually part-time professionals who have a number of different duties to fulfill. They focus on smaller Six Sigma projects. They're usually involved with gathering data, performing some sort of experiment, and analyzing information. They also assist with black belt projects. And now we're at level 4. These are individuals who have a black belt certification. They're usually team leaders of a Six Sigma project. They complete 4 to 6 projects a year and are experts in the principles, methodologies, and lean concepts. Thanks to their understanding of statistical experimental design, they can also understand the hidden reasons behind why a particular product failed. And now we're at level 3. These are individuals who have a master black belt certification. Now these are individuals who are experts when it comes to resources, the practices, and the methodologies that are employed in Six Sigma. Their main emphasis is to coach, train, and certify black belts. They also are involved with other Six Sigma leaders to ensure a company's goals are met. Now level 2. These individuals are called champions. So they work really closely with the executives and usually have a role like a senior or a middle executive level role. They also have a clear understanding of what exactly is the company's vision and mission. They also understand metrics so that they can set up a Six Sigma project that lines up with the company's goals. They're responsible for removing any sort of roadblock that could hamper the success of a project. And finally, we're at level 1. These are the executives. Now these individuals represent the highest level when it comes to a Six Sigma team. Now they have training as well as experience through which they can set up Six Sigma projects that clearly line up with the company's goals. Their main emphasis is to ensure that the project is able to add value to the organization and at the end of the day is successful. Now this is when Jenny interjects. She wants to know about lean. John tells her that lean, just like Six Sigma, is another methodology. So what exactly is lean? Now lean is a methodology that has a very important ideology to make sure that there's continuous optimization of the processes and there's an elimination of waste. So what's waste? So waste is basically any part of the process that the customer doesn't want to pay for. It is a process that does not add any value to the customer. Now coming back to lean, here are some of its characteristics. Whenever decisions are being made in a lean team, the main emphasis is to understand how it exactly adds value to the customer. Every member in a lean team has a clear understanding of what exactly are the goals of the organization. It also encourages employees to push for further success even if the organization is in a good place or is already doing well. There's also an emphasis on cross-functional collaboration and communication. Lean focuses on answering the difficult question or the complex ones rather than employing short-term fixes. And with Lean, you can easily prepare for issues that can come up in the future or improvise in unexpected circumstances. So let's talk about how Lean and Six Sigma are different from one another. The Lean methodology aims to reduce waste. It does so by analyzing the workflow. It also emphasizes on minimizing resource usage and improving customer value. Now let's talk about Six Sigma. The aim of Six Sigma is to provide near perfect results. It wants to reduce costs and improve customer satisfaction. Basically, both of them are moving towards the same goal, to reduce the amount of waste and to create efficient processes. Now let's talk about the process of Lean. Now there are 5 different steps. Let's start with the first one, identifying value. You need to identify value by determining what exactly is the problem you're trying to solve for the customer. The second step is to map your value stream. You need to map the workflow of your company. You need to focus on the different actions and the people that are involved with the process. You need to be able to identify which parts of the process are able to add value and the ones that don't. The third step is to create a flow. You need to break up your work into smaller silos and visualize the workflow so that you can easily identify problems that might show up later. The next step is to establish pull. You need to set up a system through which products are created only when there is a demand or a requirement for it. Through this, you can optimize resource capacity. And finally, we're at the 5th step, which is continuous improvement. You need to ensure all your employees at all levels are involved in the continuous improvement of the process. So what exactly is Lean Six Sigma? What if you could combine the best of both worlds? The combination of Six Sigma and Lean methodology led to the creation of Lean Six Sigma. Lean Six Sigma is a methodology that aims to solve problems, removes any form of waste or inefficiency, and improving the working conditions of employees to make sure that they can serve the customers better. Now, this is a combination of the tools, methods, and principles that are employed in Lean and Six Sigma. Let's talk about some of its advantages. It aims to provide customers with a better experience by streamlining the process. With efficient power flows, it aims to drive higher results. It can reduce cost, remove waste, and prevent defects. It can help the organization handle day-to-day problems. The decreased lead times help increase capacity and profitability. And finally, it helps with people development and improving the morale of the organization.
The organizational benefits of Six Sigma are as follows. A Six Sigma process eliminates the root cause of problems and defects in a process. Sometimes the solution is creating robust products and services that mitigate the impact of a variable input or output on a customer's experience. For example, many electrical utility systems have voltage variability up to and sometimes exceeding a 10% deviation from nominal value. Thus, most electrical products are built to tolerate the variability, drawing more amperage without damage to any components or the unit itself. Using Six Sigma reduces variation in a process and thereby reduces waste in a process. It ensures customer satisfaction and provides process standardization. Rework is substantially reduced because one gets it right the very first time. Further, Six Sigma addresses the key business requirement. Six Sigma can also be used by organizations to gain advantage and become world leaders in their respective fields. Ultimately, the whole Six Sigma process is to satisfy customers and achieve organizational goals. Let us understand how Six Sigma works in this screen. Six Sigma is successful because of the following reasons. Six Sigma is a management strategy. It creates an environment where the management supports Six Sigma as a business strategy and not as a standalone approach or a program to satisfy some public relations need. Six Sigma mainly emphasizes the DMAIC method of problem solving. Focus teams are assigned well-defined projects that directly influence the organization's bottom line with customer satisfaction and increased quality being byproducts. Six Sigma also requires extensive use of statistical methods.
The term Lean refers to creating more value to customers with fewer resources. It means reducing unwanted activities or processes that do not add value to the product or service for the customer. The Lean philosophy is to provide perfect value to the customer through a perfect value creation process that has zero waste. While the ultimate goal is to achieve zero waste, you may not always get that in the first couple of tries. However, you will achieve minimum waste and continue to move towards zero waste eventually. Hence, Lean is the path towards perfection. Lean is about optimizing the process from beginning to end, eliminating non-value-adding activities, NVAs, and increasing flow to ensure that parts and services are provided to customers more quickly. If quality is the word to describe Six Sigma, then speed is the word to describe Lean. Let's understand the importance of Lean. There are many benefits of Lean, and some of them are reduced cost, reduce cycle time, more throughput, and increase productivity. Despite all of these benefits, Lean is not implemented by most of the organizations because of the misconception that it is only suited in manufacturing areas. The reason for this misconception is the beginning of Lean. It began and grew in popularity in the manufacturing areas, starting with Toyota. In recent years, one can notice more applications of Lean in other areas, such as healthcare and the transactional space. However, the truth is that Lean concepts can be applied in any business and in any process. On the next screen, let's discuss how Lean and Six Sigma combine. Lean and Six Sigma are two different principles or methodologies that combine to form and create one powerful continuous improvement methodology. They have various overlapping goals toward the improvement, with the aim of creating the most efficient system. Though the approaches are different, the methods complement each other. Lean Six Sigma takes the power and rigor of Six Sigma methodology and combines it with Lean concepts, leading to faster results, better quality, and improved customer satisfaction. Let's look at the differences between Lean and Six Sigma. Lean focuses on efficiency by identifying value from the customer's point of view, removing unnecessary steps in the process, and improving process speed or velocity. On the other hand, Six Sigma focuses on effectiveness with the help of breakthrough processes, identifying root causes, and reduction in variation. Therefore, when Six Sigma is combined with Lean, it is possible to achieve business transformation. So remember, Lean is about speed with a focus on efficiency, Six Sigma is about quality with a focus on effectiveness, and Lean Six Sigma brings the best of both together. To yield a better result, first implement Lean to streamline the process. This helps to understand the chronic problems and the ways to handle them quickly. Once the problem is identified, use Six Sigma methodology to analyze the issues and provide business improvement transformation. In other words, Lean is used to reduce the waste and Six Sigma is used to reduce the variation.
We will discuss the basics of Six Sigma and organizational goals. Let us start with an introduction to Six Sigma in the following screen. Six Sigma is a highly disciplined process that focuses on delivering near-perfect products and services consistently. Its strength is that it's a continuous improvement process with an unwavering focus on change empowerment, seamless training of resources, and continuous top management support. These three are known as the pillars of Six Sigma. If Six Sigma is implemented methodically, it will give sustained results for any process. Now the question arises as to what is a process. This will be explained in the next screen. A process is a series of steps designed to produce a product and/or service according to the requirement of the customer. A process mainly consists of four parts: input, process steps, output, and feedback. Input is something put into a process or expended in its operation to achieve an output or a result. For example, man, material, machine, and management. Output is the final product delivered to an internal or external customer. For example, product or services. It is important to understand that if the output of a process is an input for another process, the latter process is the internal customer. Each input can be classified as controllable, represented as C, non-controllable, represented as NC, noise, represented as N, and critical, represented as X. The most important aspect of the process is the feedback. As can be inferred from the image, any change in the inputs causes change in the output. Therefore, Y equals F of X. Feedback helps in process control because it suggests changes to the inputs. Let us learn about the process of Six Sigma in the next screen. Let us understand how Six Sigma works in this screen. Six Sigma is successful because of the following reasons. Six Sigma is a management strategy. It creates an environment where the management supports Six Sigma as a business strategy and not as a standalone approach or a program to satisfy some public relations need. Six Sigma mainly emphasizes the DMAIC method of problem solving. Focus teams are assigned well-defined projects that directly influence the organization's bottom line with customer satisfaction and increased quality being byproducts. Six Sigma also requires extensive use of statistical methods. The next screen will focus on some key terms used in Six Sigma. Let us look at the Sigma level chart in this screen. As discussed earlier, the Six Sigma quality means 3.4 defects in 1 million opportunities, or a process with a 99.99966% yield. The Sigma level chart given on the screen shows the values for other Sigma levels. Please take a look at the values carefully. Let us understand the benefits of Six Sigma in the next screen. The organizational benefits of Six Sigma are as follows. A Six Sigma process eliminates the root cause of problems and defects in a process. Sometimes, the solution is creating robust products and services that mitigate the impact of a variable input or output on a customer's experience. For example, many electrical utility systems have voltage variability up to and sometimes exceeding a 10% deviation from nominal value. Thus, most electrical products are built to tolerate the variability, drawing more amperage without damage to any components or the unit itself. Using Six Sigma reduces variation in a process and thereby reduces waste in a process. It ensures customer satisfaction and provides process standardization. Rework is substantially reduced because one gets it right the very first time. Further, Six Sigma addresses the key business requirement. Six Sigma can also be used by organizations to gain advantage and become world leaders in their respective fields. Ultimately, the whole Six Sigma process is to satisfy customers and achieve organizational goals. In the next screen, let us understand Six Sigma and quality. Taking a process to Six Sigma level ensures that the quality of the product is maintained. The primary goal of improved quality is increased profits for the organization. In very simple terms, quality is defined as the degree of excellence of a product or a service provided to the customer. It is conformance to customer requirement. If the customer is satisfied with the product or service, then the product or service is of the required quality. Let us look at the history of quality in the next screen. In the mid-1930s, Statistical Process Control, SPC, was developed by Walter Shewhart and used extensively during World War II to quickly expand the U.S.'s industrial capabilities. SPC is the application of statistical techniques to control any process. Walter Shewhart's work on the common cause of variation and special cause of variation, assignable, has been used proactively in all Six Sigma projects. The approach to quality has varied from time to time. In the 1960s, there were quality circles, which originated in Japan. It was started by Kaoru Ishikawa. Quality circles were self-improvement groups composed of a small number of employees belonging to a single department. Quality circles brought in improvements with little or no help from the top management. In 1987, ISO 9000 was introduced. ISO stands for International Organization for Standardization. ISO 9000 is a set of international standards on quality management and quality assurance to help organizations implement quality management systems. ISO 9000 is still in effect. Baldrige Award, now known as the Malcolm Baldrige National Quality Award, was developed by the U.S. Congress in 1987 to raise awareness of quality management systems as well as recognize and award U.S. companies that have successfully implemented quality management systems. In 1988, another quality approach was developed known as benchmarking. In this approach, an organization measures its performance against the best organizations in its field, determines how such performance levels were achieved, and the information is used by the organization to improve itself. Then in the 1990s, there was the balanced scorecard approach. It is a management tool that helps managers of all levels to monitor their results in their key areas so that one metric is not optimized while another is ignored. During the year 1996 through 1997, an approach known as re-engineering was developed. This approach involved the restructuring of an entire organization and its processes. Integrating various functional tasks into cross-functional processes is one of the examples of re-engineering. In the next screen, let us find out about the quality gurus and their contribution to the field of quality. Let us focus on Six Sigma and the business system in this screen. Business systems are designed to implement a process or a set of processes. A business system ensures that process inputs are at the right place and at the right time so that each step of the process has the resource it needs. A business system design should be responsible for collecting and analyzing data so that continual improvement of its processes, products, and services is ensured. A business system has processes, sub-processes, and steps as its subsets. Human resources, manufacturing, and marketing are some examples of processes in a business system. Six Sigma improves a business system by continuously removing the defects in its processes and also by sustaining the changes. A defective item is any product or service that a customer would reject. A customer can be the user of the ultimate product or service, or can be the next process downstream in the business system. Let us learn about Six Sigma projects and organizational goals in the following screen. Let us understand the structure of the Six Sigma team in this screen. There are totally 5 levels in the Six Sigma screen. The first level consists of the top executives of the organization. These people lead change and provide direction as they own the vision of the organization. For any improvement initiative to work, it is important that top management of the organization be actively involved in its propagation. The top executives own the Six Sigma initiatives. Next in the level are Six Sigma champions. They identify and scope projects, develop deployment and strategy, and support cultural change. They also identify and coach Master Black Belts. 3 to 4 Master Black Belts work under every champion. Six Sigma Master Black Belts train and coach Black Belts, Green Belts, and various functional leaders of the organization. They usually have at least 3 to 4 Black Belts under them. The fourth level in Six Sigma structure is Six Sigma Black Belts. They apply strategies to specific projects and lead and direct teams to execute projects. Finally, there are Six Sigma Green Belts. They support the Black Belt employees by participating in project teams. Green Belts play a dual role. They work on the project and perform day-to-day jobs related to their work area. In the next screen, we will understand the drivers and metrics of organizational strategy. While financial accounting is useful to track physical assets, the Balanced Scorecard, or BSC, offers a more holistic approach to strategy implementation and performance measurement by taking into account perspectives other than the financial one. For an organization, traditional strategic activities that concentrate only on financial metrics are not sufficient to predict future performance. They are not sufficient to implement and control the strategic plan either. BSC translates the organizational strategy into actionable objectives that can be met on an everyday basis and provides a framework for performance measurement. The Balanced Scorecard helps clarify the organizational vision and mission to workable action items to be carried out and measured. It also provides feedback on both internal business processes and external outcomes. By doing so, it enables continuous improvement in strategic performance toward achieving organizational goals. The Balanced Scorecard achieves all this by integrating the organizational strategy with a limited number of key metrics from 4 major areas of performance: finance, customer relations, internal processes, and learning and growth. Many organizations in the world use Balanced Scorecard approaches, and the number is increasing every day. In the next screen, we will describe the Balanced Scorecard framework. We will learn about developing a Balanced Scorecard in this screen. While applying the Balanced Scorecard in an organization, care must be taken to account for interactions between different perspectives or strategic business units and avoid optimizing the results of one at the expense of another. To outline the strategy, a top-down approach is followed by determining the strategic objectives, measures, targets, and initiatives for each perspective. The strategic objectives refer to the strategy to be achieved in that perspective. 3 or 4 leading objectives are agreed upon. The progress toward strategic objectives is assessed using specific measures. These measures should be closely related to the actual performance drivers. This enables effectively evaluating progress. High-level metrics are linked to lower-level operational measures. The target values for each measure are set. The initiatives required to achieve the target value are identified. As already mentioned, this exercise is carried out for all the perspectives. Finally, the scorecard is integrated into the management system. In the next screen, let us understand the change in the approach to the balanced scorecard from the 4-box model of BSC to strategy maps. In earlier approaches to the balanced scorecard, the perspectives were presented in a 4-box model. This kind of scorecard was more a comprehensive glance at the key performance indicators or metrics in different perspectives. However, the key performance indicators or metrics of different perspectives were viewed independent of each other, which led to a silo-based approach and lack of integration. However, modern scorecards place the focus on the interrelations between the objectives and metrics of different perspectives and how they support each other. A well-designed, balanced scorecard recognizes the influence of one perspective on another and the effect of these interactions on organizational strategy. To achieve the objectives in one perspective, it is necessary to achieve the objectives in another perspective. In short, the 4 perspectives form a chain of cause and effect relationships. A map of interlinked objectives from each perspective is created. These objectives represent the performance drivers, which determine the effectiveness of strategy implementation. This is called a strategy map. The function of a strategy map is to outline what the organization wants to accomplish and how it plans to accomplish it. The strategy map is one-page view of how the organization can create value. For example, financial success is dependent on giving customers what they want, which in turn depends on the internal processes and learning and growth at an individual level. In the next screen, we will look at the impact of the balanced scorecard on the organization. The balanced scorecard and strategy map force managers to consider cause and effect relationships, which leads to better identification of key drivers and a more rounded approach to strategic planning. The BSC enables the organization to improve in the following ways. Being a one-page document, a strategy map can easily be communicated and facilitates understanding at all levels of the organization. An organization is successful in meeting its objectives only when everyone understands the strategy. The balanced scorecard also forces an organization to measure what really matters and manage information better so that quality of decision-making is higher. Creating performance reports against a balanced scorecard allows for a structured approach to reporting progress. It also enables organizations to create reports and dashboards to communicate performance transparently and meaningfully. As expected, a balanced scorecard helps an organization to better align itself and its processes to the strategic goals outlined in the BSC. The overall objectives of the BSC can be cascaded into each business unit to enable that unit to work toward the common organizational goal. All the activities of the organization, such as budgeting or risk management, are automatically aligned to the strategic objectives. To conclude, the balanced scorecard is a simple and powerful tool that, when implemented correctly, equips an organization to perform better. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will look at what lean is and how lean is applied to a process. Let us start with the lean concepts in the next screen. Let us look at the process issues in this screen. Lean focuses on 3 major issues in a process, known by their Japanese names, Muda, Mura, and Muri. Muda refers to non-value-adding work. Mura represents unevenness, and Muri represents overburden. Together, they represent the key aspects in lean. Let us look at the types of waste in the next screen. There are 7 types of muda or waste as per lean principles. Let us understand these 7 types of muda. Overproduction. This refers to producing more than is required. For example, a customer needed 10 products and 12 were delivered. Inventory. In simple words, this refers to stock. The term inventory includes finished goods, semi-finished goods, raw materials, supplies kept in waiting, and some of the work in progress. For example, test scripts waiting to be executed by the testing team, defects, repairs, rejects, any product or service deemed unusable by the customer or any effort to make it usable to the original customer or a new customer. For example, errors found in the source code of a payroll module by quality control team. Motion, a waste due to poor ergonomics of the workplace. For example, finance and account teams sit on the first floor, but invoices to customers are printed on the ground floor, causing unnecessary personnel movement. Overprocessing, additional process on a product or service to remove unnecessary attribute or feature is overprocessing. For example, a customer needs a bottle and you deliver a bottle with extra plastic casing. A customer needs ABEC3 bearing and your process is tuned to produce more precise ABEC7 bearings, taking more time for something the customer doesn't need. Waiting. When a part waits for processing or the operator waits for work, the wastage of waiting occurs. For example, improper scheduling of staff members. Transport. When the product moves unnecessarily in the process without adding value. For example, a product is finished and yet it travels 10 kilometers to the warehouse before it gets shipped to the customer. Another example, an electronic form is transferred to 12 people, some of them seeing the form more than once. That is, the form is traveling over the same space multiple times. Next, we will look at lean wastes other than the 7 types of waste discussed. Some lean experts talk about additional areas of waste. Underutilized skills. Skills are underutilized when the workforce has capabilities that are not being fully used toward productive efforts. People are assigned to jobs in which they do not fit. Underperforming processes. Automation of poorly performing process. Improving a process that should be eliminated if possible. For example, the product returns department or product discounts process. Asymmetry in processes that should be eliminated. For example, 2 signatures to approve a cost reduction and 6 signatures to reverse a cost reduction that created higher costs in other areas. In the next screen, we will look at an exercise on identifying the waste type. We will cover each step of the lean process in the next few screens. In this screen, we will learn about the first step, identify value. To implement lean to a process, it is important to find out what the customer wants. Once this is done, the process should be evaluated to identify what it needs to possess to meet customer requirements. The next screen will focus on the next step of the lean process, value stream mapping. In this screen, we will discuss the differences between push and pull processes. An organization can adopt either of these processes depending on the requirement. Contrary to a pull process, in a push process, the first step is to forecast the demand for a product or service. The production line then begins to fill this demand and produced parts are stocked in anticipation of customer demand. For example, a garments manufacturer produces 200 shirts based on expected demand, and then waits for customer orders for them. Note that the demand is expected and not actual. Discounts offered to customers by big retailers are examples of the push process. If the garment company adopts a pull process instead, it would start making the shirts only after receiving a confirmed demand from customers. Note that although the pull approach seems better, it is not applicable to all situations. For example, a pharmacy uses a push process. In the next screen, we will learn about theory of constraints. Let us look at an example for the TOC methodology in this screen. The 3 sub-processes in the packing process are coding or printing, filling, and sealing. The data for the 3 sub-processes are observed and collected as number of units produced in an hour. The data is as follows. Coding or printing is 900 units per hour. Filling is 720 units per hour, and sealing is 780 units per hour. How can you implement the TOC methodology in this example? Let us build the TOC map for this example. The first step in the TOC methodology is to identify the constraint. Looking at the data, the output per hour from the filling process is 720. This is the constraint in the system. In the second step, the constraint is exploited by analyzing the performance using data. To break the constraint, a repair and maintenance personnel can be assigned to maintain the filling machine on a daily basis. In the third step, the other fixes in the repair and maintenance function are made as subordinate decisions to the one taken in step 2. In this example, carry out the maintenance of the filling machine. In the fourth step, the constraint is elevated by implementing the decisions. In this example, remove the damages from the filling machine. The next step is to go back to step 1 and identify the next system constraint. As per the data collected after implementation of the first cycle of the TOC, sealing can be identified as the next system constraint. Let us now analyze the data before and after TOC implementation in this example. The number of units produced per hour before implementing the TOC in coding or printing process was 900 units. Filling process was 720 units, and sealing process was 780 units. After implementing the TOC, the number of units produced per hour for the filling process increased to 840 from 720 units. Let us proceed to the next topic of this lesson. In this topic, we will discuss the concepts in Design for Six Sigma, or DFSS. Let us first understand DFSS in the next screen. DFSS, or Design for Six Sigma, is a business process methodology that ensures that any new product or service meets customer requirements, and the process for that product or service is already at Six Sigma level. DFSS uses tools such as Quality Function Deployment, or QFD, and Failure Mode and Effects Analysis, or FMEA. DFSS can help a business system to introduce an entirely new product or service for the customer. It can also be used to introduce a new category of product or service for the business system. For example, an FMCG company plans to make a new brand of hair oil, a type of product already in the market. DFSS also improves the product or service and adds to the current product or service lines. To implement DFSS, a business system has to know its customer requirements. DFSS can be used to design a new product or service, a new process for a new product or service, or redesign of an existing product or service to meet customer requirements. Let us learn about processes for DFSS in the next screen. The two major processes for DFSS are IDOV and DMADV. IDOV stands for Identify, Design, Optimize, and Verify. DMADV stands for Define, Measure, Analyze, Design, and Verify. In the IDOV process, the first step involves identifying specific customer needs based on which the new product and business process will be designed. The next step involves design, which involves identifying functional requirements, developing alternate concepts, evaluating the alternatives, selecting a best fit concept, and predicting Sigma capability. Tools such as FMEA are used here. The third step, Optimize, uses a statistical approach to calculate tolerance with respect to the desired output. When IDOV is implemented to design a process expected to work at Six Sigma level, this is checked in the Optimize phase. If the process does not meet expectations, the Optimize phase helps in developing detailed design elements, predicting performances, and optimizing design. The last stage of IDOV is to verify, that is, to test and validate the design, and finally to check conformance to Six Sigma standards. The other process, DMADV, has 5 stages. The first stage is to define the customer requirements and goals for the process, product, or service. Next, measure and match performance to customer requirements. The third stage involves analysis and assessment of the design for the process, product, or service. The next step is to design and implement the array of latest processes required for the new process, product, or service. The final stage is to verify results and maintain performance. In the next screen, we will look at the differences between IDOV and DMADV. The primary difference between IDOV and DMADV is that while IDOV is used only to design a new product or service, DMADV can be used to design either a new product or service or redesign an existing product or service. IDOV involves design of a new process, while DMADV involves redesigning an existing process. In IDOV, no analysis or measurement of existing process is done, and the whole development is new. The design step immediately follows the identification of customer requirements. In contrast, DMADV, the existing product, service, or process, is examined thoroughly before moving to the design phase. The design stage comes only after defining requirements and analyzing the existing product, service, or process. In the following screen, we will learn about Tool Quality Function Deployment, or QFD, which is one of the DFSS tools. QFD, also called Voice of Customer, or VOC, or House of Quality, is a predefined method of identifying customer requirements. It is a systematic process to understand the needs of the customer and convert them into a set of design and manufacturing requirements. QFD motivates business to focus on its customers and design products that are competitive in lesser time and at lesser cost. The primary learning from QFD includes which customer requirements are most important, what the organization's strengths and weaknesses are, where an organization should focus their efforts, and where most of the work needs to be done. To learn from QFD, the organization should ask relevant questions to customers and tabulate them to bring out a set of parameters critical to the design of the product. Apart from understanding customer requirements, it is also important to know what would happen if a particular product or service fails when being used by a customer. It is necessary to understand the effects of failure on the customer to ensure preventive actions are taken, and to be able to answer the customers in the event of failure. In the next screen, we will look at another DFSS tool, Failure Modes and Effects Analysis, or FMEA. Failure Modes and Effects Analysis, or FMEA, is a preemptive tool that helps any system to identify potential pitfalls at all levels of a business system. It helps the organization to identify and prioritize the different failure modes of its product or service and what effect the failure would have on the customer. It helps in identifying the critical areas in a system on which the organization's efforts can be focused. Note that while FMEA enables identification of critical areas, it does not offer solutions to the identified problems. We will look at the varieties of FMEA, such as DFMEA and PFMEA, in the next screen. PFMEA stands for Process Failure Mode and Effects Analysis, and DFMEA stands for Design Failure Mode and Effects Analysis. PFMEA is used on a new or existing process to uncover potential failures. It is done in the quality planning phase to act as an aid during production. A process FMEA can involve fabrication, assembly, transactions, or services. DFMEA is used in the design of a new product, service, or process to uncover potential failures. The purpose is to find out how failure modes affect the system and to reduce the effect of failure on the system. This is done before the product is sent to manufacturing. All design deficiencies are sorted out at the end of this process. In the following screen, we will understand FMEA Risk Priority Number. FMEA Risk Priority Number, or RPN, is a measure used to quantify or assess risk associated with a design or process. Assessing risk helps identify critical failure modes. Higher the RPN, higher the priority the product or process receives. RPN is a product of three numbers: severity of a failure, occurrence of a failure, and the detectability of a failure. All these numbers are given a value on a scale of 1 to 10. The minimum value of RPN is 1, and the maximum value is 1,000. A failure mode with a high occurrence rating means the failure mode occurs very frequently. A mode with a high severity rating means that the mode is really critical to ensure safety of operations. A mode with a high detection rating means that the current controls are not sufficient. In the next screen, we will look at the FMEA table. The FMEA table helps plan improvement initiatives by underlining why and how failure modes occur and helps organizations plan for their prevention. Typically, FMEA is applied on the output of root cause analysis and is a better tool for focus or prioritization as compared to multivoting. One important aspect of FMEA is that it does not need data. Experts in a particular area can form the FMEA table without having to look at data from any source. In functions such as human resources, the FMEA table is very useful, as there might not be much data available to the problem-solving team. The sample FMEA table is given on the screen. Please go through the contents for better understanding. In the following screen, we will discuss severity of risk priority number and scale criteria. Let us first discuss severity. Severity refers to the seriousness of the effect of the failure mode, or how critical the failure mode is to the customer or the process. The severity of a failure mode is rated on a scale of 1 to 10 using a severity table. Different industries follow different structures for the severity table. A high severity rating indicates a mode is critical to operational safety. For example, a team working on FMEA of a radioactive plant may insert fatal as the effect with rating 10. Another example is the severity table for a sports team. The team manager wants to rate the severity of failure of the team in an upcoming game. She might rate it at 9 given that the team would lose a big sponsorship should they face defeat, which could in turn be hazardous to the team's future. Shown here is a generalized table of severity. The severity rating can never be changed. For example, if a mode has a rating of 9 before improvement, it will continue to have a rating of 9 after improvement too. Let us look at occurrence of RPM and scale criteria. Occurrence is the probability that a specific cause will result in the particular failure mode. As with severity, occurrence is rated on a scale of 1 to 10 based on a table. Like the severity table, higher the occurrence of a failure, higher is its rating. Again, this table might vary depending on the industry and scenario. Sometimes the project team can use data here if available. Based on past data, the probability of occurrence of a failure can easily be rated. Shown here is a generalized table. Let us next look at detection of RPN and scale criteria. Detection is the probability that a particular failure will be detected. The table shown here is again a generalized one. The rating here is a bit different from severity or occurrence. Higher the detectability of a failure, lower is its rating. This is because if the failure can easily be detected, then everyone would know of it, and therefore there would be less or no damage. For example, if detection is impossible, the failure is given a rating of 10. Please note that at the start of a Six Sigma project, the failure mode is given a relatively high detection rating. Let us look at an example of FMEA and RPN in the next screen. In this example, a bank wants to recognize and prioritize the risks involved in the process of withdrawing cash from an ATM. It can be observed from the table that not having a control in place for network issues has the highest RPN. This is due to the detectability for a network issue being very low. The next set of information in the table shows the action taken by the bank's management to address the failure modes. Following the implementation, the new RPN is calculated, retaining the security level at 9. This is because the actions were not directed at reducing the severity, but at the causes of failure. It can be seen that the new RPN is much lower, and the risk for both causes has been mitigated.
We introduce you Lean Six Sigma Green Belt Certification Training course by Simplilearn. Become an expert. Grab the course now. Find the course link in the description box.
This lesson will cover the details of the define phase. Let us start with the objectives of the lesson in the next screen. After completing this lesson, you will be able to explain various components of project identification, describe customer data collection methods, list various means of project documentation, discuss risk analysis and management, describe project management and planning tools, explain the concepts used in evaluation of project performance, discuss team stages and dynamics. Let us start with the first topic in the following screen. In this topic, we will discuss project identification. Let us see the prerequisites of a Six Sigma project in the following screen. Six Sigma can be applied to everything around. It can be applied across almost 70 different sectors. However, it cannot be applied to all problems. The first step is to check if the project qualifies to be a Six Sigma project. The questions that need to be asked are as follows. Is there an existing process? To implement the DMAIC methodology of problem solving, a process needs to exist. The process should be in operation for the development of the product or service. Is there a problem in the process? Ideally, the process should not have any problem. If there is a problem in the process performance, the process needs to be improved. Is the problem measurable? The problem has to be measurable in order to assess the root cause and the impact of the problem on the process. Does the problem impact customer satisfaction? If the problem affects customer satisfaction, an action needs to be taken immediately, else the customer may start finding alternate products or switch to competitors' products. Does working on the problem impact profits of the company? It is very essential to assess the impact of the project on the profits of the company. If the project affects the profits of the company adversely, then such a project is not feasible. Is the root cause of the problem unknown? If the root cause of the problem is visible, then a Six Sigma project is not required. Other problem-solving techniques can be used in this case. Is the solution unknown? If the solution to the problem is already known, then there is no need for any project. The company can directly implement the solution. The define phase of DMAIC will be introduced in the next screen. The Six Sigma project process is known as a DMAIC process. Define is the first phase in the Six Sigma project process. In the define phase, the problem is defined and the Six Sigma team is formed. The objectives of the define phase are as follows. Clearly define the problem statement through customer analysis. Understand customer requirements, and ensure that the Six Sigma project goals are aligned to these requirements. Define the objectives of the Six Sigma project. Plan the project in terms of time, budget, and resource requirements. Define the team structure for the project and establish roles and responsibilities. In the next screen, let us learn about benchmarking. Benchmarking is the process of comparing an organization's business processes, practices, and performance metrics with that of industry leaders. There are various types of benchmarking. Let us briefly look at each type. Process benchmarking entails comparing specific processes to a leading company or an industry standard. This is useful to obtain a simplified view of business operations and enables a focused review of major business functions. Process benchmarking includes comparisons of production processes, data collection processes, performance indicators, and productivity and efficiency reviews. Financial benchmarking is performed to assess overall competitiveness and productivity. It is done by running a detailed financial analysis and analyzing the result. Performance benchmarking involves comparison of products and services with those of competitors, with the intention of evaluating the organization's competitiveness. Product benchmarking involves designing new products or services or upgrading existing products or services. This can involve reverse engineering a competitor's products to study the strengths and weaknesses and modeling the new product on these findings. Strategic benchmarking refers to studying strategies and problem-solving approaches in other industries. Functional benchmarking is the focused analysis of a single function with the aim of improving it. Complex functions may need to be divided into processes before benchmarking is done. Competitive benchmarking includes standardizing organizational strategies, process, products, services, and procedures against the competitors in the same industry. Collaborative benchmarking is a type of benchmarking where the standardization of various business parameters is carried out by a group of companies and the information is shared. If the subsidiary units of a company or its various branches carry out the benchmarking, it is called collaborative benchmarking. Let us take a look at best practices for benchmarking in the next screen. Best practice is a method that ensures continuous improvement, leading to exceptional performance. It is also a method to sustain and develop the process continuously. Some of the best practices in benchmarking are as follows. Increase the objectives or scope of benchmarking. Set the standards and path to be followed at the initial stage. Reduce unnecessary effort and comply with the scope. Recognize the best in the industry to set a benchmark. Share the information derived from benchmarking. In the next screen, we will discuss project selection. Let us understand process, business process, and business system in this screen. A process is a series of steps designed to produce a product or service to meet the requirement of a customer. A process mainly consists of three elements: input, process, and output. A business process is a systematic organization of objects, such as people, machinery, and materials, into work activities designed to produce a required product or service. As shown on the screen, a process is a subset of a business process. A business process is, in turn, a part of a business system. A business system is a value-added chain of various business processes, such as sales or finance. For example, payroll calculation is a process in the HR business process of an IT company, which is a business system. In the next screen, we will look at the process elements. Let us discuss the challenges to business process improvement in this screen. The improvement to a business process of an organization faces challenges due to the traditional business system structure, because it is generally grouped around the functional aspect. The main problem in a functionally grouped organization is the movement or flow of a product or service. A product or service has to go through various functions and their functional elements to reach the customer or end user. The other problem is management of the flow of products or services across various functional elements. This is difficult as usually there is no one in charge. These business process improvement problems can be solved using the project management approach to produce the product or service. In the next screen, we will learn about process owners and different stakeholders of a project. The representation of where the process owner and stakeholders are placed in the organizational hierarchy is on the screen. The process owner is a person at a senior level in the hierarchy. He is the one who takes responsibility for the performance and execution of a process, and also has the authority and the ability to make necessary changes. On the other hand, a stakeholder is a person, group, or organization which is affected or can affect an organization's actions. Businesses have many stakeholders like stockholders, customers, suppliers, company management, employees of an organization and their families, the society, etc. Let us discuss the effects of process failure on various stakeholders in the next screen. While it is an absolute business necessity to keep one's stakeholders satisfied at all times, failure to meet one or more process objectives may result in negative effects on them. In such situations, for the stockholders, the perceived value for the company gets reduced. Customers may seek other competitors for their deals, while imposing penalties and finding recourse in legal action against the company. Suppliers may be on the losing front with delayed payments or not being paid at all. Company management may require cost cut-down. Employees will receive diminishing wages. The community and society will be affected due to pollution created by the organization. In the next screen, we will understand the relationship between business and the stakeholder. In the diagram shown on the screen, each stakeholder is both a supplier as well as a customer, forming many closed-loop processes that must be managed, controlled, balanced, and optimized for the business to thrive. Communication is the key in such situations and is facilitated through internal company processes. The next screen covers the importance and relevance of stakeholder analysis. Stakeholder analysis is an important task to be completed before doing a Six Sigma project. A business has many stakeholders, and any change to a business process affects some or all of them. When a process does not meet its objectives, it results in the stakeholders being negatively affected, which in turn affects the organization's performance. The Six Sigma team must factor in the reasons why a stakeholder may oppose the change effort. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will discuss voice of the customer. Let us start with how to identify the customer in the following screen. Customers are the most important part of any business. A customer is someone who decides to purchase, pays, consumes, and gets affected by a particular product or service. It is critical to identify and understand the customer requirements. The products or services can be designed according to these requirements. Consequently, the company is able to provide products or services the customers are willing to purchase. There are two types of customers: internal and external customers. In the next screen, we will learn about internal customers. An internal customer can be defined as anyone within the business system who is affected by the product or the service while it is being developed. Most often, internal customers are the employees of the company. For example, let us assume that there is a series of processes in a particular business system. In such a scenario, the second process is the internal customer for the first process. The third process is an internal customer for the second process, and so on. The basic needs of an internal customer are to be provided proper tools and necessary equipment, imparted proper training, and given specific instructions to carry out their responsibilities. However, the needs are not limited to these alone. Other needs include the provision of company newsletters, projects, storyboards to display the letters, etc., team meetings to share business news and announcements, staff meeting to share information, and quality awards from suppliers. An internal customer is important. First of all, the activities of an internal customer directly affect the final or ultimate customer. Secondly, the activities of an internal customer affect the next process in the system. Finally, an internal customer also affects the quality of the product developed or service provided. When the needs of the internal customers, in most cases employees, are met, they are more likely to have higher perceptions of quality and also contribute to greater productivity. The satisfaction levels of the internal customers can be improved in various ways. These include a higher amount of internal communication through company newsletters and team meetings, recognitions for work, quality awards, etc. Constant training on how to be ahead and well-equipped in a competitive environment is very essential too. In the next screen, we will learn about external customers. This screen focuses on the positive effects of a project on the customers. The most important aspect of any process improvement project is the customers. Internal customers are the ones who drive the project. Hence, the effect of the project on internal customers is a critical factor that needs to be considered. The positive impact of a project on the internal customers is as follows. The project is driven by highly motivated individuals or internal customers who are aware of the project objectives and scope. Individuals belonging to a credible project understand the project deliverables and display high levels of job satisfaction. These individuals go the extra mile to take up tasks beyond their job description. Such individuals make a highly motivated team focused on delivering their responsibilities in order to meet the customer requirements. Working together in a positive environment also improves team spirit and bonding. The positive impact of a project on the external customers is as follows. Process improvement projects analyze the problems and come up with an effective solution, consequently ensuring a better product. A successful process improvement project assists the organization in effectively meeting customer expectations or requirements. There is visible improvement in customer service. Good quality product and service ensures high customer satisfaction. Let us learn about different methods of customer data collection in the following screen. Once you begin to identify the customer types, you need to look forward to collecting customer data. Collecting data from customers is very essential, as it helps consider the levels at which these customers affect the business. Begin by collecting feedback from both internal as well as external customers. Customer feedback helps fill the gaps and improve the various business processes in the organization. It helps define a good quality product as perceived by the customer and identify qualities that make the competitor's products or service better. It also helps identify factors which provide a competitive edge to the product or service on offer. There are various methods to collect feedback from the customers. Many of you might be involved in a similar activity at some point or the other. Popular and common methods are surveys conducted through questionnaires, focus groups, individual interviews with the customers. Customer complaints received via call centers, emails, and feedback forms are also quite prevalent. Feedback received in this form are from dissatisfied customers. In the next screen, we will learn about questionnaires. Let us discuss the advantages and disadvantages of questionnaires in this screen. The advantages of a questionnaire are that it costs less. The phone response rate is high, anywhere from around 70 to 90%, and it produces faster results. Also, analysis of mail questionnaires requires few trained resources. Questionnaire is a method used to gather data. However, there are a few disadvantages associated with it. There may be incomplete results and unanswered questions leading to a lack of clarity. The response rate of mail surveys is about 20 to 30% only. At times, phone surveys can produce undesirable results, as the interviewer can influence the person being interviewed. We will differentiate between telephone survey and web survey in the next screen. There are different methods to collect data for a survey. The methods need to be based on the requirements and needs of the organization. The popular methods of survey are the telephone survey and web survey. Both have their own drawbacks and benefits, which are given on the screen. The organization needs to choose a method of collecting data according to the situation. It is recommended to go through the content for a better understanding. In the next screen, we will learn about focus groups. Let us now discuss the advantages and disadvantages of using a focus group for data collection. The interaction in a focus group generates information, provides in-depth responses, and can address more complex questions or qualitative data. It is an excellent platform to get critical to quality or CTQ definitions as well. On the other hand, the disadvantages of focus groups are that the learning only applies to those within the group, and it is not possible to generalize. The information collected is more qualitative than quantitative, which is another drawback. Additionally, they can also generate a lot of information from anecdotes and incidents experienced by the individuals in the group. In the next screen, we will discuss the interview technique. This screen discusses advantages and disadvantages of using the interview technique for data collection. Interviews have a capability to handle complex questions and a large amount of information. They also allow us to use visual aids in the process. It is a better method to be employed when people do not respond willingly and/or accurately by phone or email. However, there are some shortcomings as well. Interviews are time-consuming, and the resources or interviewer needs to be trained and experienced to carry out the task. Let us discuss the importance and urgency of these inputs in the next screen. The table shows the importance and urgency of different kinds of input. To understand the kind of input to be chosen, different kinds of methods for collecting data are identified. Telephone survey, web survey, and interview are the data collection methods identified. To select the best methods, the criteria or the factors which are important to the organization are listed. The criteria are the factors based on which an organization is going to make decisions. The list of factors is then given weightage based on the importance of each factor in decision-making. As seen, cost is the most important criterion for which the weightage is given 20. Response rate of the customer is next important factor, and the list follows. Visualizing feature and compiling and analyzing data are the factors which have the lowest impact on the decision of selecting the methods for data collection. Each of the data collecting methods is rated between 1 and 10, based on its impact on the listed factors, with 10 being highly favorable to the organization and 1 being least favorable. After rating all the methods with the factors listed, the sum or total is calculated. The calculation of the total involves multiplying each method's rating with the factor weightage and adding all the multiplied values of the column. That is, for telephone survey, the rating is multiplied with factors rating. 8 multiplied by 12 plus 8 multiplied by 6 plus 3 multiplied by 20 plus 5 multiplied by 5 plus 3 multiplied by 5 plus 7 multiplied by 15 plus 1 multiplied by 10 plus 7 multiplied by 3 plus 0 multiplied by 2 plus 3 multiplied by 2 plus 1 multiplied by 10 plus 7 multiplied by 5 plus 8 multiplied by 5. And the total of this is 471. In a similar way, calculate the total value for the remaining two methods. The total of other two methods are 744 and 522, respectively. Looking at the overall total of the methods, 744 is the highest. Hence, web survey is the best method for the organization to use for data collection. Let us look at the pros and cons of customer complaints data in the next screen. There are pros and cons in gathering information from customer complaints. Advantages include availability of specific feedback directly from the customer, and ease in responding appropriately to every customer. On the contrary, feedback in this method does not provide an adequate sample size and may lead to process changes based on one or two inputs from the customer. The next screen will discuss the difference between product complaint and expedited service request. Product complaints and expedited service requests can act as inputs to the company for improving their process. These details address the needs of the customer in an indirect way. A product complaint means that the customer is not happy with the product that he has purchased from the company. An expedited service request means a service request is being rushed. If the customer requires the items immediately, then an expedited service request is raised from the customer, and the organization tries to fulfill it to please the customer. Product complaint implies that a product is not meeting customer specification, hence it has to be improved. Expedited service request implies that service timeliness are not meeting customer requirements, hence service has to be improved. Product complaint also implies that the customer needs for product are not completely identified, whereas expedited service request implies that the customer timings need to be recalculated. Let us discuss the importance and urgency of these inputs in the next screen. The table shows the importance and urgency of different kinds of input. To select the best methods, the criteria or the factors which are important to the organization are listed. The criteria are the factors based on which organization is going to make decisions. These factors are then given weightage based on the importance of each factor in decision making. As seen, cost involved and identification of customer need are the most important criteria for which the weightage given is 15, and the list follows. Time consumption and compiling and analyzing data are the factors which have the least impact on the decision of selecting the methods for data collection. Each method is rated between 1 and 10 based on its impact of the listed factors, with 10 being highly favorable to the organization and 1 being least favorable to the organization. After rating all the methods with the factors listed, the sum or total is calculated. Calculation of the total is derived by multiplying each method's rating with the factor weightage and adding all the multiplied values. That is, for product complaint, the rating is multiplied with the factor's rating. 8 multiplied by 15 plus 4 multiplied by 15 plus 3 multiplied by 2 plus 1 multiplied by 10 plus 1 multiplied by 10 plus 1 multiplied by 10 plus 1 multiplied by 8 plus 1 multiplied by 10 plus 4 multiplied by 2 plus 1 multiplied by 8 plus 1 multiplied by 10. And the total of this is 260. In the similar way, calculate the total value for expedited service request. The total of expedited service request is 817, and hence it is effective to the organization. Let us discuss the key elements of data collection tools in the next screen. Data collection tools will be selected based on the type of data to be collected. The key elements that make these tools effective are as follows. Data is collected directly from the primary source or customer. Hence, there is no scope for miscommunication or loss of information. Data is collected exclusively for the stated purpose. Hence, data is highly reliable. The data is captured after understanding the organizational purpose. This makes the data exclusively relevant and serves the purpose of the organization. Data is collected instantaneously when there is a requirement. This ensures that the data is up to date. Hence, the data is valid. The tools accurately define customer requirements. The customer requirements could be current needs or improvement to the product or service that they are currently using. The tools help to get enough information about customer requirement through which the process for improving or creating the product or service that the customer requires can be developed. In the next screen, we will discuss how the collected data can be reviewed. Collated data must be reviewed to eliminate vagueness, ambiguity, and any unintended bias. Nutra Worldwide buys laptops for its employees from a company that is into manufacture and sales of laptops. The company also provides servicing and repairs for their products to the customers. To understand the level of customer satisfaction in Nutra Worldwide and to improve its process, the laptop company is conducting a survey. The questionnaire, which was prepared initially, questionnaire before review, had questions that led to ambiguity, vagueness, and unintended bias. Let us look at each item on the survey. To understand the level of usage of the laptop and to know their customer better, the survey is raising a question related to the occupation of the customer. It gives the option of student or professional. But with this low amount of information, the company is neither able to gather the information, nor will the given option cover the entire possible occupation in the market. Including an option of other, please specify, would help the customer to choose and provide the information, if he does not belong to one of the two given groups. Hence, the same is added in the review so that the customer will not be in any ambiguity while filling the questionnaire. The question whether the sales executive was supportive, with an option of yes or no, is a question which leads again to ambiguity and unintended bias. The customer might be partially happy or partially not happy, but the choice does not let them inform their exact feeling. If the customer selects no as the option, then the company does not get enough information to understand where their sales executive went wrong. Hence, in the reviewed questionnaire, the customer is asked to rate the qualities of their sales executive, which will provide better data to the company in order to improve the process. Next, we will discuss a technique named Voice of Customer. The Voice of Customer is a technique to organize, analyze, and profile the customer's requirements. Voice of the Customer is an expression for listening to the external customer. The table shows the customer requirements while purchasing an air conditioner. In all cases, the customer is purchasing for his or her domestic usage. Each customer is further categorized according to his needs and requirements. When the customer says that he needs a silent air conditioner, he needs sound sleep at night in the bedroom. This is primarily to remain fresh the next morning and to get rid of the noisy ceiling fan being used currently. In case the customer says that he needs an efficient AC, he needs a machine which provides good cooling at night in the bedroom. This is mainly because it gets extremely hot in summer. Also, he currently uses a ceiling fan which is not so effective in summers. On the other hand, when the customer wants to buy an AC which is not too costly, he has limited cash for the purchase. He wants to purchase a low-cost AC. Let us discuss the importance of translating customer requirements in the next screen. Customer requirement is the data collected from customers that gives information about what they need or want from the process. Customer requirements are often high-level, vague, and non-specific. Some customers may give you a set of specific requirements to the business, but broadly, customers' requirements are a reflection of their experience. Customer requirements, when translated into critical process requirements that are specific and measurable, are called critical to quality CTQ factors. A fully developed CTQ has four major elements: output characteristic, Y metric, target, and specification or tolerance limits. We will discuss the meaning of CTQ in the next screen. Let us understand what quality function deployment is in this screen. QFD is a process to ensure that the customer's wants and needs are heard and translated into technical characteristics. It is also known as the voice of the customer or house of quality. QFD is a process to understand the customer's needs and translate them into a set of design and manufacturing requirements, while motivating businesses to focus on their customers. It also helps companies to design and build more competitive products in less time and lesser costs. QFD helps in prioritizing customer requirements, recognizing strengths and weaknesses of an organization, and recognizing areas that need to be worked on and areas that need immediate focus of efforts. QFD is carried out by asking relevant questions to the customers and tabulating them to bring out a set of parameters critical to the product design. Let us discuss phases of QFD in the next screen. Quality function deployment involves 4 phases. Phase 1, product planning. In this phase, the QFD team translates the customer requirements into product technical requirements. Phase 2, product design. In this phase, the QFD team translates the identified technical requirements into key part characteristics or systems. Phase 3, process planning. In this phase, the QFD team identifies the key process operations necessary to achieve the identified key part characteristics. Phase 4, production planning, or process control. In this phase, the QFD team establishes process control plans, maintenance plans, and training plans to control operations. Next, we will understand the structure of QFD. Let us see what happens after completing the HOQ matrix. Completing one HOQ matrix is not the end of the QFD process. The output of the first HOQ matrix can be the first stage of the second QFD phase. As shown in the image, the translation process is continued using linked HOQ type matrices until the production planning targets are developed. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will discuss the basics of project management. Let us start with a discussion on problem statement. Every Six Sigma project targets a problem that needs to be resolved. The first step of project initiation is defining the problem statement. A problem statement needs to describe the problem in a clear and concise manner. A problem statement needs to identify and specify the observed gap in performance. It should indicate the current performance state of a process and the required performance state completely derived from customer requirements. A problem statement should be quantifiable. This means it should have specified metrics including the respective units. Please note that the problem statement cannot contain solutions or causes for the problem. In the next screen, we will discuss the is or is not template. The is or is not technique was first popularized by Kepner-Trigot Incorporated in the 1970s. It is a powerful tool that helps define the problem and gather required information. An example of a problem statement of paper cup leaks is given on the screen. The Six Sigma team has to answer what is the problem, what isn't the problem, where is it, where isn't it, when isn't it a problem, to what extent is it a problem, and to what extent isn't it a problem. The information is then used to fill the question areas in the is and is not issue template. In the analysis phase, if a cause cannot describe the is and the is not data, then it's not likely the main cause. In the next screen, we will list the criteria for the project objectives. The project objectives must meet the SMARTS criteria. SMARTS is an acronym of the characteristics desired in project objectives: specific, measurable, attainable, relevant, time-based, and stretch. The project deliverables should be specific. Example: hospitals maintain records of all patients. Often, a few forms are rejected or missed due to errors in recording the ID numbers. In this case, setting the objective as reduce form rejection is very vague. Instead, reduce patient ID errors in recording lab results is specific and effectively targets solving the problem. The project objectives should be quantifiable. Example: setting the objective as fewer form rejections is very vague. Instead, reduce patient ID errors by 30% sets a specific goal. The project objectives should be achievable and practical. The project objectives should be relevant to the problem. The project objectives must specify a time frame within which they should be delivered. The project objectives must not be easily achievable. Example: most problems and errors can be reduced by creating awareness. Hence, the objective must stretch beyond the easily attainable state. In the next screen, we will understand project documentation. Project documentation refers to creating documents to provide details about the project. Such documents are used to gain a better understanding of the project, prevent and resolve conflict among stakeholders, and share plans and status for the project. Documentation of a project is critical throughout the project. Some of the benefits achieved through project documentation are mentioned below. Documentation serves as written proof for execution of the project. It helps teams achieve a common understanding of the requirements and the status of the project. It removes personal bias as there is a documented history of discussions and decisions made for the project. Depending on the nature of the project, each project produces a number of different documents. Some of these documents are the project charter, project plan, and its subsidiary plans. Other examples of project documentation include project status reports, including key milestones report, risk items, and pending action items. The frequency of these reports is determined by the need and complexity of the project. These reports are sent to all stakeholders to keep them abreast of the status of the project. Another example of project documentation is the final project report. This report is prepared at the end of the project and includes a summary of the complete project. Project storyboard, inputs generated from statistical tools, outputs from spreadsheets, checklists, and other miscellaneous documents are also classified as project documents. In the next screen, we will understand project charter. We will list the project charter sections in this screen. The major sections of a project charter are project name and description, business requirements, name of the project manager, project purpose or justification, including ROI, stakeholder and stakeholder requirements, broad timelines, major deliverables, constraints and assumptions, and the budget summary of the charter. In the next screen, we will understand the project plan. A project plan is the final approved document which is used to manage and control the various processes within the project and ensure its seamless execution. The project manager uses the project charter as an input to create a detailed project plan. A project plan comprises various sections, prominent among them being the project management approach, the scope statement, the work breakdown structure, the cost estimates, scheduling, defining performance baselines, marking major milestones to be achieved, and the key members and required staff personnel for the project. It also includes the various open and pending decisions related to the project and the key risks involved. Additionally, it also contains references to other subsidiary plans for managing risk, scope, schedule, etc. In the next screen, we will learn about project scope. We will look at different techniques used for interpreting the project scope in this screen. Project scope can be interpreted from the problem statement and project charter using various tools like the Pareto chart and the SIPOC map. The principle behind the Pareto chart, or the 80-20 principle as we know it, is a vital few, trivial many. The Pareto chart helps the teams to trim the scope of the project by identifying the causes which have a major impact on the outcome of the project. The SIPOC map is a high-level process map, which helps all team members in understanding the process functions in terms of addressing questions like who are the suppliers? What are the inputs they provide? What are the outputs that can be obtained? And who are the customers? As discussed earlier, SIPOC stands for suppliers, inputs, process, outputs, and customers. In the subsequent screen, we will learn about process maps. SIPOC is a macro-level map that provides an overview of the business process, where a process map is a micro-level flowchart that provides an in-depth detail of a process. The process map covers details at all levels and provides a walk through the current process experience. The SIPOC map is used as a basis while drawing a process map. A Level 1 process map provides in-depth information, but the final process map drills further into detail. In the following screen, we will understand the project metrics. Let us discuss consequential metrics in this screen. Consequential metrics measure any negative consequences. These can be business metrics, process metrics, or both. They measure the negative effects of improving the primary or key metrics. They are used to measure the indemnity triggered by any damage in the project. The inconsistent use of consequential metrics can lead to loss of opportunity and rework after a project ends. Consequential metrics help to understand the cause and effect relationship between the primary and the secondary metrics, and the impact it has on the organization. Let us take a look at an example for consequential metrics in the next screen. We will discuss the best practices in this screen. The following are some of the best practices of consequential metrics. Setting consequential metrics during the measure phase and monitoring these metrics after finalizing the project will help to analyze whether the link between previous primary and secondary metrics has been established. Also, linking consequential metrics with primary metrics, and finally linking them with secondary metrics, provides clarity on the impact of these metrics. Assessing and evaluating the cause and effect relationship between these metrics is helpful to the organization as a whole. In the next screen, we will list some project planning tools. The project manager uses various tools to plan and control a project. One of the tools which he uses is the Pareto chart. Other prominent tools include the network diagram, the critical path method, also called CPM, the program evaluation and review technique, which is also known as PERT, Gantt charts, and the work breakdown structure, also known as WBS. In the next screen, we will discuss Pareto chart. Pareto chart is a histogram ordered by the frequency of occurrence of events. It is also known as the 80-20 rule, or vital few, trivial many. It helps project teams to focus on the issues which cause the highest number of defects or complaints. To explain further, the given chart plots all the causes for defects in a product or service. The values are represented in descending order by bars, and the cumulative total is represented by the line. Pareto chart emphasizes that 80% of the effects come from 20% of the causes. Thus, a Pareto chart narrows the scope of the project or problem solving by identifying the major causes affecting quality. Pareto charts are useful only when required data is available. If data is not available, then other tools, such as brainstorming and multivoting, should be used to find the root cause of any problem. In the following screen, we will continue to discuss Pareto chart with an example. A hotel receives plenty of complaints from its customers, and the hotel manager wishes to identify the key areas of complaints. Complaints were received in the following areas: cleaning, check-in, pool timings, minibar, room service, and miscellaneous. Cleaning and check-in can be noted as areas of concern, with 35 and 19 complaints respectively. Percentage is calculated for each cause of complaint, and the cumulative is derived. Pareto chart is plotted using this data. In the next screen, we will discuss network diagrams. Network diagrams are one of the tools used by the project manager for project planning. They are also sometimes referred to as arrow diagrams because they use arrows to connect activities and represent precedents and interdependencies between activities of a project. There are some assumptions that need to be made while forming the network diagram. The first assumption is that before a new activity begins, all pending activities have been completed. The second assumption is that all arrows indicate logical precedence. This means that the direction of the arrow represents the sequence that activities need to follow. The last assumption is that a network diagram must start from a single event and end with a single event. There cannot be multiple start and end points to the network diagram. In the next screen, let us discuss some terms related to network diagram. For the network diagram to calculate the total duration of the project manager needs to define 4 dates for each task. The first 2 dates relate to the date by when the task can be started. The first date is early start. This is the earliest date by when the task can start. The second date is late start. This is the last date by when the task should start. The second two dates relate to the dates when the task should be complete. Early finish is the earliest date by when the task can be completed. Late finish is the last date by when the task should be completed. The duration of the task is calculated as the difference between the early start and early finish of the task. The difference between the early start and late start of the task is called the slack time available for the task. Slack can also be calculated as the difference between the early finish and late finish dates of the task. Slack time, or float time for a task, is the amount of time the task can be delayed before it causes a delay in the overall project timeline. In the next screen, we will discuss critical path method. Critical path method, also known as CPM, is an important tool used by project managers to monitor the progress of the project and to ensure that the project is on schedule. The critical path for a project is the longest sequence of tasks on the network diagram. The critical path in the given network diagram is highlighted in orange. Critical path is characterized by zero slack for all tasks on the sequence. This means that the smallest delay in any of the tasks on the critical path will cause a delay in the overall timeline of the project. This makes it very important for the project manager to closely monitor the tasks on the critical path and ensure that the tasks go smoothly. If needed, the project manager can divert resources from other tasks that are not on the critical path to tasks on the critical path to ensure that the project is not delayed. When a project manager removes resources from such tasks, he needs to ensure that the task does not become a critical path task because of the reduced number of resources. During the execution of the project, the critical path can easily shift because of multiple factors and hence needs to be constantly monitored by the project manager. A complex project can also have multiple critical paths. In the next screen, we will discuss project evaluation and review technique. We will understand the concept of risk in this screen. Risk is an uncertain event or consequence probable of occurring during a project. The main objectives of any project are time, cost, quality, and scope. Risk affects at least one of the four project objectives. It is important to understand that risk can be both positive as well as negative. A positive risk enhances the success of the project, whereas a negative risk is a threat to a project's success. Some of the terms used in risk analysis and management are risk probability, issue, and risk consequences. The likelihood that a risk will occur is called risk probability. To assess any risk is to assess the probability and impact of the risk. Issue is the occurrence of a risk. Risk consequences are the effects on project objectives if there is an occurrence of a risk or issue. In the subsequent screen, we will understand the process of risk analysis and management. We will list and understand some of the elements of risk analysis in this screen. Qualitative method. Qualitative methods like interview, checklists, and brainstorming are used to identify potential risks. Quantitative method. Quantitative methods are data-based, and a computer is required to calculate and analyze. These methods are used to evaluate the cost, time, and probabilistic combination of individual uncertainties. Feasibility. Feasibility is the study of the project risk. This is usually carried out in the beginning of the project when the project is most flexible and risks can be reduced at a relatively low cost. It helps in deciding different implementing options for the projects. Potential impact. Once the potential risks are identified, the impact of these on the project is determined. Using this data, possible solutions for the risks are identified. RPN. RPN of a failure is the product of its probability of occurrence, severity, and detectability. A failure is prioritized based on its RPN value. A high RPN indicates high risk. RPN assists to prioritize risks. Avoiding risk. When potential risks are identified, their impact in terms of cost, time, resources, and objective perspective is calculated. If the impact is huge, then avoiding the risk is the best option. Mitigating risk. Mitigating is the second option when dealing with risks. The loss that arises from mitigating a risk is much less than the loss that arises from the temporary avoiding of risk. Accepting the risk. If a risk cannot be avoided or mitigated, then it has to be accepted. The risk will be accepted if it doesn't greatly impact the cost, time, and product objective. In the following screen, we will discuss benefits of risk analysis. Benefits of risk analysis are as follows. Once the risk has been identified, it can be either mitigated, transferred, or accepted. When risk is identified in a task, slack time is provided as a buffer. Identifying risks also helps in setting up an actual timeline for a project. Slack time for an activity in a project could be the result of a risk identified proactively. Identifying risks helps in setting realistic expectations from the project by communicating the risk probability and consequence to stakeholders. Risk analysis also helps to identify and plan contingency activities if the risk becomes an issue. The project team is then well prepared to work on the issue, thereby reducing the impact of the risk. In the following screen, we will take a look at the risk assessment matrix. The potential risks of a project are assessed using the risk assessment matrix. It covers potential risk areas like project scope, team, personnel, material, facility and equipment, and communication. Each of these areas is assessed in terms of risk of loss of money, productivity, resources, and customer confidence. In the subsequent screen, we will discuss project closure. By definition, a project has a beginning and an end. But without a formal closure process, project teams can fail to recognize the end, and then the project can drag on, sometimes at great expense. Every project requires closure. For large or complex projects, it's a good idea to close each major project phase, for example, design, code, and test individually. Project closure ensures that outcomes match the stated goals of the project. Customers and stakeholders are happy with the results. Critical knowledge is captured. The team feels a sense of completion, and project resources are released for new projects. In the next screen, we will list the goals of a project closure report. The project closure report is created to accomplish the following goals. Review and validate the success of the project. Confirm outstanding issues, limitations, and recommendations. Outline tasks and activities accomplished to complete the activity. Highlight the best practices for future projects. Provide the project report or summary. Provide a project background overview. Summarize the planned activities of a project. Evaluate project performance. Provide a synopsis of the process. Generate discussions and recommendations. Generate project closure recommendations. In the following screen, we will list and understand project closure activities. During project closure, the project manager needs to take care of the following activities. Finalize the project documents. Much of a project's documentation is created during the life of the project. Document collection and update procedures are well established during the project lifeline. Capture the project knowledge. Project documents are helpful for future projects, in troubleshooting the product, or in a future audit. Set up a project library. Ideally, the project library is set up at the beginning of the project, and team members add documents as they produce them. Document the project learnings. Project learnings can be captured through team meetings, meetings with stakeholders, and sponsor, and through feedbacks from consultants and vendors. Provide knowledge transfer. The project manager needs to provide a summary of the project results to team members, either as a presentation at a meeting or as a formal document. Consultants should not be relieved from their position until they have transferred all the important product maintenance knowledge to the team. Get a final sign-off. Schedule a meeting with the project sponsor and key stakeholders to get their final sign-off on the project. Close the project office. If the project team used a project management office or a dedicated work area, arrangements need to be made to return that space for general use. Recognize and reward. The project manager has the best understanding of which of the team members have worked the best, have transformed themselves with new skills, and who might be ready for a new level of responsibility. The project manager needs to report to the team's superiors what each team member has brought to the project. Celebrate. After completion of every project, the team needs and deserves a celebration. A team dinner, a team outing, gift certificates, or other rewards are minor costs that generate a large return in terms of morale and job satisfaction. Make a public announcement. An announcement to the organization is a good way to highlight the success of the project and its benefits to the company. Conclude. Formal project closure ensures that the team has met its objectives, satisfied the customer, captured important knowledge, and been rewarded for their efforts. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will discuss management and planning tools. Let us start with a discussion on affinity diagram in the next screen. The affinity diagram method is employed by an individual or team to solve unfamiliar problems. It is an effective medium where the consensus of the group is necessary. The given affinity diagram is based on an organization where the employees are not satisfied. To begin with, each member writes down ideas and opinions on sticky notes. Each note can have a single idea. The points which have surfaced during the brainstorming session are that the workers are unkind, pay is low, and it is difficult to survive on the pay structure, working hours are too long, etc. In the next step, all the sticky notes are pasted on a table or wall. The sticky papers are arranged according to categories or thought patterns. Members happen to arrange their ideas based on affinity. In case a particular idea is good to go into more than one category, it is duplicated and added to several categories. After the arrangement is done, each category is named with a header card. The header card captures the central idea of all the cards in that category and draws a boundary around them. Poor compensation combines ideas like low pay, long working hours, and complaints about wages. Poor work environment encompasses issues like poor lighting, uncomfortable rooms, and stuffy air. Similarly, poor relationships prevail in the workspace as the workers are unkind and there is mutual dislike. Lack of motivation is due to repetitive work and no work-related challenges. You can see in the diagram on that slide that once all the ideas are grouped to the respective header cards, a diagram is drawn and borders are placed around the group of ideas. Thus, affinity diagram helps in grouping ideas with a common theme. In the next screen, we will discuss the interrelationship diagram. During problem solving, the interrelationship diagram technique helps in identifying the relationship between problems and ideas in complex situations. If the problem is really complex, it may not be easy to determine the exact relationship between ideas. The given interrelationship diagram is the result of a team brainstorming session, which identified 10 major issues involved in developing an organization's quality plan. Initially, the problem is defined, and all the members put down their ideas on sticky notes. Each note contains only one idea. All the sticky notes are put on a table for a random display. In the next step, The causes or areas of concern are identified, and a cause-effect arrangement of cards is constructed by drawing an arrow between the causes and effects of the cause. This is done until all the ideas on the sticky notes are accounted for and made a part of the interrelationship diagram. Take a large sheet of paper and replicate the cause-effect arrangement on it. As depicted in the image, a large number of outgoing arrows indicate the root cause, whereas a higher number of incoming arrows indicates an outcome. There are as many as 6 arrows originating from lack of quality strategy. This leads us to understand that it is a root cause. On the other hand, there are 3 arrows ending with the idea lack of TQM commitment by managers, making it an outcome. In the next screen, we will understand the tree diagram. The tree diagram is a systematic approach to outline all the details needed to complete a given objective. In other words, it is a method used to identify the tasks and methods needed to solve a problem and reach a predefined goal. It is mostly used while developing actions to execute a solution, while analyzing processes in detail during the evaluation of implementation issues for several potential solutions, and also as a communication tool to explain the details of a process to others. The given tree diagram shows the plan of a coffee shop trying to set standards for the coffee it delivers. First, the objective is noted on a note card and placed on the far left side of the board. The basic goal of the coffee shop is to provide a delightful cappuccino experience. In the next step, the coffee shop needs to determine the means required to achieve the goal and furnish 3 different solutions. In other words, the answers to the how or why questions of the objectives. In this case, the cappuccino needs to be at a comfortable temperature, and it should have strong and pleasing coffee aroma with the right amount of sweetness. In the next step, the 3 issues mentioned in the second stage are addressed at length. Each issue is answered. By maintaining the espresso and steamed milk temperature, the cappuccino can be served at a palatable temperature. Strong flavored cappuccino can be prepared using a good amount of finely ground coffee beans. And a good quality sweetener, used in the right amount, makes a great cappuccino. Thus, the tree diagram can be used to achieve a goal or define a process. In the following screen, we will discuss prioritization matrices. Let us learn about matrix diagram in this screen. Matrix diagrams show the relationship between objectives and methods, results and causes, tasks and people, etc. Their objective is to provide information about the relationship. They provide importance of task and method elements of the subject. They also help determine the strength of relationships between a grid of rows and columns. They help in organizing a large amount of inter-process related activities. Let us discuss various types of matrices in the next screen. Let us learn about a process decision program chart in this screen. Process decision program chart, or the PDPC method, is used to chart the course of events from the beginning of a process till the goal. While emphasizing the ability to identify the failure of important issues on activity plans, the PDPC helps create appropriate contingency plans to limit the number of risks involved. The PDPC is used before implementing a plan, especially when the plan is large and complex, if the plan must be completed on schedule, or if the price of failure is quite high. The given process decision program chart shows the process which can help in securing a contract. The process starts when the seller receives an order request from a potential buyer. This can lead to fixing an appointment with the buyer, confirming the appointment date, and meeting the buyer. If a date is not fixed, then buyer should be contacted till the meeting is confirmed. Without a meeting, there is a risk of losing the order. Considering an optimistic scenario, where a meeting is fixed with the buyer, the seller describes the price of the product or service. If the price is competitive, the order is secured. If the price is not competitive, the seller may have to repeat the bid until the buyer agrees and the order is secure. However, the buyer may not agree to a revised bid either, in which case the seller might lose the bid. In such a scenario, the seller can justify the pricing and pursue the buyer to agree to the bid. It might work, and the seller might secure the order. In the next screen, we will discuss the activity network diagram. An activity network diagram is used to show the time required for solving a problem and to identify items that can be done in parallel. It is used in scheduling and monitoring tasks within a complex project or process with interrelated tasks and resources. Moreover, it is also used when you know the steps of the project or process, their sequence, and the time taken by each of the steps involved. The original Japanese name for this tool is arrow diagram. The given activity network diagram shows a house construction plan and identifies the factors involved separately, like the amount of time for each operation in one situation, the relationship of work without time for each operation, and an operation by itself. The number of days is denoted by D. So the time taken for an activity like foundation to scaffolding takes around 5 days plus 4 days, which is 9 days in total. The line joining electrical work and interior walls is dotted. This shows relation between them, but without any timeline. Basically, it means that electrical work has to be done before interior walls, but the time is either not important or not available. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will introduce business results for projects. Let us start with the discussion on defect per unit. We will learn about throughput yield in this screen. Throughput yield, or TPY, is the number of acceptable pieces at the end of a process divided by the number of starting pieces, excluding scrap and rework. Throughput yield is used to measure a single process only. If the DPU is known, TPY can be easily calculated as e to the power of the negative of DPU. Here, e is the mathematical constant and has a value of 2.7183. The expression can also be stated as DPU equals the negative of natural logarithm e of TPY. In the next screen, we will discuss rolled throughput yield. Rolled throughput yield, or RTY, is the probability of the entire process producing 0 defects. RTY is the true measure of process efficiency and is considered across multiple processes. It is important as a metric when a process has excessive rework. TDPU is total defects per unit and is defined for a set of processes. When the total defects per unit is known, rolled throughput yield is calculated using the expression e to the power of negative of TDPU. The expression can also be written as TDPU is equal to negative of natural logarithm of RTY. When the defectives are known, rolled throughput yield can be calculated as the product of each process's first pass yield, or FPY. First pass yield is the number of products which pass without any rework over the total number of units. First pass yield is calculated as total number of quality products over total number of units. Total number of quality products is total number of units minus total number of defective units. In the following screen, we will understand FPY and RTY with an example. We will discuss process capability in this screen. Process capability, or CP, is defined as the inherent variability of a characteristic of a process or a product. In other words, it might also mean how well a process meets customer requirement. CP is an indicator of capability of a process and is expressed as difference of USL and LSL divided by product of Six Sigma. USL stands for Upper Specification Limit. LSL is Lower Specification Limit, and Sigma is the standard deviation of a process. The difference between USL and LSL is also called the specification width or tolerance. In the following screen, we will discuss Process Capability Indices. Process Capability Indices, or CPK, was developed to objectively measure the degree to which a process meets or does not meet customer requirements. It was developed to account for the position of mean with respect to USL and LSL. To calculate CPK, the first step is to determine if the process mean is closer to the LSL or the USL. If the process mean is closer to LSL, CPKL is determined. CPKL is mean minus LSL divided by product of 3 and sigma. If the process mean is closer to USL, CPKU is calculated. CPKU is USL minus mean divided by product of 3 and sigma. Here, mean is the process average, and sigma represents the standard deviation. If the process mean is equidistant, either of the specification limit can be chosen. CPK takes up the value of CPKU and CPKL, depending on whichever is the lower value. In the next screen, we will understand process capability indices with an example. In this screen, we will discuss CPK and CP interpretations. A CP value of less than 1 indicates the process is not capable. Even if CP is greater than 1, to ascertain if the process really is not capable, check the CPK value. A CPK value of less than 1 indicates that the process is definitely not capable, but might be if CP is greater than 1 and the process mean is at or near the midpoint of the tolerance range. The CPK value will always be less than CP, especially as long as the process mean is not at the center of the process tolerance range. Non-centering can happen when the process has not understood the customer expectations clearly, or the process is complete as soon as the output reaches a specific limit. For example, a shirt size of 40 has a target chest diameter of 40 inches, but the process consistently delivers shirts with a mean of 41 inches as the chest diameter. A machine stops removing material as soon as the measured dimension is within specified limit. Let us proceed to the next topic of this lesson in the following screen. In this topic, we will discuss team dynamics and performance. Let us start with a discussion on team stages. There are 5 typical stages in the team building process. Each team passes through these stages as they start and proceed through the project. The 5 stages in the team building process are as follows: forming, storming, norming, performing, and adjourning. In the next screen, we will discuss the first stage, forming. The first stage in the team building process is called the forming stage. In this stage, the team comes together and begins to formulate roles and responsibilities. The team leader is identified, and he or she starts directing the team and assigning responsibilities to other team members. Most team members at this stage are generally enthusiastic and motivated by a desire to be accepted within the team. The leader employs a directive style of management, which includes delegating responsibility within the team, providing a structure to the team, and determining processes needed for the smooth functioning of the team. Toward the end of this phase, the team should achieve a commitment to the project and an acceptance of a common purpose. In the next screen, we will discuss the second stage, storming. The second phase in the team building process is called the storming stage. As suggested by the name itself, in this stage, conflicts start to arise within the team. Team members often struggle over responsibilities and control within the project. It is the responsibility of the team leader to coach and conciliate the team. The leader employs a coaching style of management which is reflected through facilitating change, managing conflict, and mediating understanding between different parties. Towards the end of this phase, team members need to learn to voice disagreement openly and constructively while staying focused on common objectives and areas of agreement. In the next screen, we will discuss the third stage, norming. The third stage in the team building process is called the norming stage. In this stage, people get along, and the team develops a unified commitment toward the project goal. The team leader promotes the team and participates in the team activities. Team members look to the leader to clarify their understanding as some leadership roles begin to shift within the lower rungs of the group. The leader employs a participatory style of management through facilitating change, working to build consensus, and overseeing quality control. Toward the end of this phase, team members need to accept individual responsibilities and work out agreements about team procedures. In the next screen, we will discuss the fourth stage, performing. The next stage in the team building process is called the performing stage. This is the most productive stage for the project team. In this stage, team members manage complex tasks and work toward the common goals of the project. The leader employs a supervisory style of management by overseeing progress, rewarding achievement, and supervising process. The team leader leads the project on more or less an automated mode. When the project has completed successfully, or when the end is in sight, the team moves into the final stage. In the next screen, we will discuss the fifth stage, adjourning. The last stage of team building is called the adjourning stage. In this stage, the project is winding down, and the goals are within reach. The team members are dealing with their impending separation from the team. The team leader provides feedback to the team. The leader employs a supportive style of management by giving feedback, celebrating accomplishments, and providing closure. The team leader needs to adopt a different style of leadership at every stage. It is therefore important for a leader to understand these stages and identify the current stage that a team is in. The success of the team depends on how well the leader can guide them through these phases. In the next screen, we will learn about negative dynamics. Team members can exhibit negative behavior in more than one way during the project life cycle. This behavior has a negative effect on the dynamics of the team. The first kind of negative participants fall in the category of overbearing participants. These participants use their influence or expertise to take on a position of authority, discounting contributions from other team members. To cope with such participants, team leaders must establish ground rules for participation and reinforce that the group has the right to explore any area pertinent to team goals and objectives. Another kind of negative participant is often referred to as the dominant participant. These participants take up an excessive amount of group time by talking too much, focusing on trivial concerns, and otherwise preventing participation by others. Team leaders need to be able to control dominant participants without inhibiting their energy or enthusiasm. Some other participants are reluctant participants, who feel intimidated and are not happy with the team process. Owing to their reluctance, they miss opportunities to bring up data that is valuable to the project. This can often lead to hostility within the team. One way to deal with reluctant participants is to respond positively and with encouragement to any contribution from the team member. Teamwork is more than a natural consequence of working together. Team management is more than building a relationship with individual team members. All teams face group challenges that need group-based diagnosis and problem solving to ensure that negative participants are able to contribute and perform as part of the team. In the next screen, we will learn about group challenges. Six Sigma team and their responsibilities are described here. Various roles assist the smooth execution of a Six Sigma project. These roles are required to support the project by providing the information and resources that are needed to execute the project. The first important member of the Six Sigma team is the executive sponsor. Sponsors are the source or conduit for project resources, and they are usually the recipients of the benefits the project will produce. The sponsor is responsible for setting the direction and priorities for the organization. The sponsor may be a functional manager or an external customer. The next important role is that of the process owners. They work with the black belts to improve their respective processes. They provide functional expertise about the process to the project. Usually, this role is played by the functional managers in charge of specific processes. The next role in the project is that of the champions. They are typically upper-level managers who control and allocate resources to promote process improvements. They ensure the organization is providing necessary resources to the project, and the project is fitting into the strategic plans of the organization. The first role related to the execution of the project is the role of the Master Black Belt. This role acts as a consultant to team leaders and offers expertise in the use of Six Sigma tools and methodologies. Master Black Belts are experts in Six Sigma statistical tools and are qualified to teach high-level Six Sigma methodologies and applications. Each Master Black Belt will have multiple Black Belts under him. Black Belts are the leaders of individual Six Sigma projects. They lead project teams and conduct the detailed analysis required in Six Sigma methodologies. Black Belts act as instructors and mentors for Green Belts and educate them in Six Sigma tools and methods. They also protect the interests of the project by coordinating with functional managers. Green Belts are trained in Six Sigma, but typically lead project teams working in their own areas of expertise. They are focused on the basic Six Sigma tools for acceleration of projects. Green Belts work on projects on a part-time basis, dividing time between project and functional responsibilities. An executive is the person who manages and leads the team to ensure smooth working of tasks and has the power to execute decisions. A coach takes on a number of roles. He or she is the person who trains, mentors, teaches, and guides the team when required. Coach also motivates and builds confidence of the members. A facilitator is a guide for the team or group, also known as a discussion leader. Facilitators help the group or team to understand their common objective and plan their activities. A sponsor is a person who supports the event or the project by providing all the required resources. A team member is an individual who belongs to a particular project team. A team member contributes to the performance of the team and actively participates for fulfillment of the project objectives. The progress, achievements, and the details of the project have to be effectively communicated to the team, management, customers, and stakeholders. We will learn about modes of communication in the next screen. Let us understand communication within the team in this screen. The purpose of communication within the team and the modes of communication used are as follows. Meetings and emails are suitable to communicate the roles and responsibilities of the team members. Meetings, memos, and emails are used by the team to understand the project status. Workshops and meetings are conducted to identify the outstanding tasks, risks, and their corrective actions. Team meetings assist decision-making. Meetings and emails ensure coordination and efficient work. The next screen will focus on communication with stakeholders. The purpose of communication with stakeholders and the modes of communication used are as follows. Meeting, emails, and events are suitable to convey project objectives and goals to stakeholders. Meetings, emails, and newsletters assist stakeholders in understanding project status. Workshops, meetings, and events help stakeholders to identify the adverse effects of a situation. Meetings with stakeholders assist decision-making process. In the next screen, we will discuss the communication technique. Communication techniques can be grouped in various ways. The first grouping of communication techniques is based on the direction in which communication flows. Vertical communication consists of two subtypes, namely downward flow of communication and upward flow of communication. In the downward flow of communication, the managers must pass information and give orders and directives to the lower levels in the organization. On the contrary, upward communication consists of information relayed from the bottom or grassroots levels to the higher levels of the company. Horizontal communication refers to the sharing of information across the same levels of the organization. This can be in the form of formal and informal communication. Formal communications are official company-sanctioned methods of communicating to the employees. The grapevine, rumor mill, etc. are some of the means of informal communication in the organization. The second grouping of communication techniques is based on the usage of words. Verbal communication includes use of words for communication, via telephone, face-to-face, etc. Nonverbal communication conveys messages without the use of words through body language, facial expressions, etc. The last grouping of communication techniques is based on participation of the people involved in communication. One-way communication happens when information is relayed from the sender to the receiver without the expectation of a response, like memos and announcements. Two-way communication is a method in which both parties are involved in the exchange of information. Team tools are a part of the team dynamics and performance. The various team tools that are used are brainstorming, nominal group technique, and multivoting. We will learn about each of these in the forthcoming screens.
We introduce you Lean Six Sigma Green Belt Certification Training course by Simplilearn. Become an expert. Grab the course now. Find the course link in the description box.
Six Sigma process is known as DMAIC. DMAIC comprises 5 phases: define, measure, analyze, improve, and control. These phases are the roadmap to problem solving and improving our processes. The effectiveness of Six Sigma method is derived from its structure. Each phase has an overarching objective and specific deliverables that need to be completed, which helps us achieve the objectives. The purpose of the define phase is to document the problem, the desired outcome, goals, and deliverables. The purpose of the measure phase is to obtain baseline process performance levels and quantify the problem. The focus of the analyze phase is to identify the key root causes for process variation and defects. The purpose of the improve phase is to develop, test, and implement the solutions. The goal of the control phase is to monitor the key factors and maintain the gains. You learn the aspects of the DMAIC process. Now we'll look at the tools used in each phase. The list of tools corresponds to the DMAIC phase in which they are used. The use or application of these tools gives the expected deliverables in each DMAIC phase for a Greenbelt. Some of the tools listed are not required in every Six Sigma Greenbelt project. These tools give us an insight into the problem and lead us toward the real issues in our processes. That is, with more experience, you are likely to know the tools you need for your projects. In the define phase, we use SIPOC, Voice of the Customer or VOC, Critical to Quality, CTQ, the Quality Function Deployment or QFD, Failure Modes and Effects Analysis, known as the FMEA or the FMEA, and the Cause and Effect CNE matrix. In the measure phase, we use Measurement System Analysis or MSA, control charts, process capability, and normality plots. In the analyze phase, we use Simple Linear Regression or SLR, Pareto charts, fishbone diagram, failure modes and effects analysis, the familia, multivariate charts, and hypothesis testing. In the improve phase, we use brainstorming, piloting, and also the failure modes effects analysis and design of experiments, DOE. In the last phase, control, we use control charts, a control plan, and measurement system analysis.
Pareto chart is a histogram ordered by the frequency of occurrence of events. It is also known as the 80-20 rule, or vital few, trivial many. It helps project teams to focus on the issues which cause the highest number of defects or complaints. To explain further, the given chart plots all the causes for defects in a product or service. The values are represented in descending order by bars, and the cumulative total is represented by the line. Pareto chart emphasizes that 80% of the effects come from 20% of the causes. Thus, a Pareto chart narrows the scope of the project or problem solving by identifying the major causes affecting quality. Pareto charts are useful only when required data is available. If data is not available, then other tools, such as brainstorming and multivoting, should be used to find the root cause of any problem. Network diagrams are one of the tools used by the project manager for project planning. They are also sometimes referred to as arrow diagrams because they use arrows to connect activities and represent precedents and interdependencies between activities of a project. There are some assumptions that need to be made while forming the network diagram. The first assumption is that before a new activity begins, all pending activities have been completed. The second assumption is that all arrows indicate logical precedence. This means that the direction of the arrow represents the sequence that activities need to follow. The last assumption is that a network diagram must start from a single event and end with a single event. There cannot be multiple start and end points to the network diagram. Critical path method, also known as CPM, is an important tool used by project managers to monitor the progress of the project and to ensure that the project is on schedule. The critical path for a project is the longest sequence of tasks on the network diagram. The critical path in the given network diagram is highlighted in orange. Critical path is characterized by zero slack for all tasks on the sequence. This means that the smallest delay in any of the tasks on the critical path will cause a delay in the overall timeline of the project. This makes it very important for the project manager to closely monitor the tasks on the critical path and ensure that the tasks go smoothly. If needed, the project manager can divert resources from other tasks that are not on the critical path to tasks on the critical path to ensure that the project is not delayed. When a project manager removes resources from such tasks, he needs to ensure that the task does not become a critical path task because of the reduced number of resources. During the execution of the project, the critical path can easily shift because of multiple factors and hence needs to be constantly monitored by the project manager. A complex project can also have multiple critical paths.
Before we discuss some important Six Sigma interview questions, firstly let us understand what Six Sigma is. Now, Six Sigma is a data-driven methodology and set of tools aimed at improving business processes by minimizing defects, reducing variation, and achieving near-perfect levels of quality and efficiency. Now, it involves rigorous analysis, statistical techniques, and a structured problem approach to identify improvements and maintain control over processes. Well, it sounds too technical, right? So let's just understand in a simple way. Now imagine you are at a bakery and you want to eat your favorite and most delicious cupcakes. But sometimes the cupcakes may come out too dry or maybe too sweet sometimes. Very much frustrating, right? Now, well, Six Sigma is like having a secret recipe to ensure you bake the best cupcakes every single time. It's a special approach that helps businesses reduce mistakes and improve quality in their processes. With Six Sigma, you measure everything precisely and analyze data to find the root cause of the problems. Then with this knowledge at your disposal, you make improvements and set up controls to prevent those mistakes from happening again. So without any further ado, let us directly discuss some of the major interview questions that you might face in your next interview on Six Sigma. So first on the list, we have what is Six Sigma and why it is important. Now, Six Sigma is a data-driven approach and methodology for process improvement and problem solving. It is a disciplined and statistical approach to process improvement that focuses on reducing defects and variability. It utilizes various tools and techniques to identify and eliminate the root causes of the problem. So the main aim of Six Sigma is to minimize defects and variation in business processes to high levels of quality and efficiency in order to achieve them. Now the second question is, can you explain the key principles of Six Sigma? Now the key principles of Six Sigma include various methodologies like customer focus, process improvement, data-driven decision making, and teamwork. Now, customer focus means understanding and meeting customer needs and expectations. Process improvement involves systematically analyzing and enhancing business processes. Data-driven decision making emphasizes the use of statistical analysis and metrics to drive decisions. And finally, teamwork promotes collaboration and involvement of all stakeholders in process improvement efforts. Now, the next question is, what do you understand about the term DMAIC? Another crucial question in the concept of Six Sigma. Now, DMAIC is a structured problem-solving methodology used in Six Sigma projects. It stands for Define, Measure, Analyze, Improve, and Control. So, it is a step-by-step approach for process improvement. It begins with defining the problem and project goals, followed by measuring current process performance and collecting data. Now, the next steps involves analyzing the data to identify a root cause of the problems and implementing solutions to improve the process. And finally, establishing controls to sustain the improvements, altogether confined as DMAIC. So the next question is, what is the purpose of using statistical tools in Six Sigma? Now, statistical tools are used in Six Sigma to analyze data, identify patterns, measure process performance, and make data-driven decisions. These tools provide a systematic and objective approach to analyzing data and making informed decisions. They help in identifying trends, patterns, and relationships within the data, which can guide process improvement efforts. Now, some of the examples of statistical tools used in Six Sigma include control charts, hypothesis testing, process mapping, Pareto charts, regression analysis, design of experiments, or DOE. Next question on the list we have is, explain difference between DPU and DPMO. Now, DPU or defects per unit measures the average number of defects per individual unit, while defects per million opportunities or DPMO measures the number of defects per 1 million opportunities. DPU is a simple measure that counts the average number of defects found in each unit of a process. It is calculated by dividing the total number of defects by the total number of units. While on the other hand, DPMO is a normalized measure that provides a standardized way of comparing defect rates across different processes or organizations. It is calculated by multiplying DPU by 1 million and dividing by the total number of opportunities for defects in a process. So those were some of the main differences between DPU and DPMO. Well, the next question on the list we have is, what is the difference between Six Sigma and Lean? Now, the interviewer wants to know whether you have a proper knowledge on how Lean and Six Sigma are different from each other, and this is why they might be asking this question. So the answer for that would be, while both Six Sigma and Lean aim to improve process performance, Six Sigma focuses on reducing defects and variation, whereas Lean focuses on eliminating waste and improving flow. Now, Six Sigma and Lean are two complementary methodologies often used together in process improvement efforts. Six Sigma primarily aims at reducing defects, errors, and variability in processes, while Lean focuses on identifying and eliminating waste and non-value add activities to improve efficiency and flow. While both methodologies share common tools and principles and can be used in conjunction to achieve even greater results. So these were some of the main differences between Six Sigma and Lean. Well, moving ahead, the next question on our list is, what is the role of a Six Sigma Green Belt? Now, a Six Sigma Green Belt is a team member who assists in process improvement projects, gathers and analyzes data, and participates in problem-solving efforts. So basically, a Six Sigma Green Belt is a trained individual who works as a part of a Six Sigma project team. They support the project leader, that is Black Belt, in gathering and analyzing data, conducting process analysis, and implementing improvement solutions. Green Belts often lead smaller scale improvement projects and play a vital role in implementing and sustaining process changes. So moving ahead, the next question on our list is, what is the main difference between type 1 and type 2 errors in hypothesis testing? Well, type 1 errors occurs when a null hypothesis is incorrectly rejected, indicating an insignificant effect when none exists. Whereas, type 2 error occurs when a null hypothesis is incorrectly accepted, failing to detect a significant effect. Now, in hypothesis testing, type 1 error, which is also called as an alpha error, refers to the rejection of a null hypothesis when it is actually true. Well, this error indicates a false positive result, suggesting that there is a significant effect when in reality there isn't. Now, type 2 error on the other hand is also called a beta error, occurs when the null hypothesis is accepted despite it being false. Now, this error indicates a false negative result, failing to detect a significant effect that exists in reality when there is actually one in reality. So moving ahead, the next question we have is, what is process map and how it is useful in Six Sigma? Now, a process map is a visual representation of steps, activities, and outputs of a process. It basically helps in understanding and analyzing process flow, identifying inefficiencies, and finding areas for improvement. Now, a process map, which is also known as a process flow chart or a process diagram, provides a graphical representation of the sequence of steps in a process. It helps in documenting and understanding the flow of activities, inputs and outputs within a process. Now, process maps are useful tools in Six Sigma for identifying bottlenecks, redundancies, and non-value added steps, which enable process teams to visualize the current state, identify any improvement opportunities, and develop future state maps for process optimization. Well, the next question on our list is, explain what is FMEA and its purpose. Now, the purpose of conducting an FMEA is to proactively identify and prioritize potential failures in a process or product, determine their effects, and take preventive or corrective actions. Now, the full form of FMEA is defined as Failure Mode and Effect Analysis, which is a systematic method used to identify and analyze potential failure modes in a process or product, assess their severity, occurrence, and detectability, and prioritize them based on their risk. Now, FMEA helps in understanding the potential consequences of failures, identifying the root causes, and taking appropriate actions to prevent or mitigate the risks associated with these kind of failures. Alright, moving ahead, the next question on our list is, what is the concept of sigma level in Six Sigma? Now, sigma level is a statistical metric that measures the capability of a process to perform defect-free work. It indicates the number of standard deviations that can fit within the specification limits. So you can see that it is a measure of process performance in terms of defects per million opportunities or DPMO. It provides an indication of the process capability to produce products or services within the desired specification. A higher sigma level indicates a higher level of process capability and lower levels of defects. For example, a process operating at a 6 sigma level would have a defect rate of 3.4 defects per million opportunities. Well, the next question we have is, what is the purpose of control charts in Six Sigma? Now, control charts are used in Six Sigma to monitor and control process performance over time, detect variations, and distinguish between common cause and special cause variations. These are basically graphical tools that help in monitoring process performance over time. You can plot data points against control limits to determine if the process is stable or exhibiting special cause variations. Control charts provide a visual representation of process variation and help in distinguishing between common cause variation and special cause variation. By analyzing these control chart patterns, process teams can take appropriate actions to improve process stability and reduce variations overall. So that was what control charts are and why they are important. Well, the next question on our list is, explain difference between attribute data and variable data. Now, attribute data is a qualitative data that describes the presence or absence of a particular characteristic or attribute, while variable data is quantitative data that can be measured on a continuous scale. Now, attribute data is collected by counting the number of occurrences or non-occurrences of a specific characteristics. It is typically represented in terms of proportions, percentages, or count values. Now, example of attribute data include number of defects, presence of absence of special features, or the number of non-conformances. While on the other hand, variable data is collected by taking measurements on a continuous scale. Now, some of the examples of variable data include length, weight, or temperature. Variable data is typically analyzed using numerical values, such as calculating means, ranges, and standard deviations using some parametric statistical methods. So these were some of the main differences between attribute data and variable data. So moving ahead, the next question is, what is the purpose of conducting a process capability analysis? Now, the purpose of conducting a process capability analysis is to assess whether a process is capable of producing outputs that meet customer requirements and specifications. Now, process capability analysis is performed to determine if a process is capable of consistently meeting the customer specifications by calculating process capability indices such as CP and CPK, which is very important in terms of conducting a process capability analysis. Now, CPK, which is also known as Process Capability Index, measures how well a process is able to consistently produce output within the desired specifications. It helps determine if a process is capable of meeting customer requirements. Process teams can assess whether the process is capable of producing within specification limits. Overall, process capability analysis helps in understanding the level of variation in the process and identify areas for improvement to achieve desired levels of quality. And finally on the list, we have what is the concept of Design for Six Sigma or DFSS. Now, Design for Six Sigma or DFSS is a methodology used to develop new products, services, or processes within a focus of meeting customer requirements and achieving high levels of quality and performance. It is a proactive approach to product or process development that emphasizes meeting customer needs and achieving high levels of quality from the outset. It utilizes various tools and techniques such as QFD, quality function deployment, robust design, and risk analysis to ensure the customer requirements are effectively translated into product or process specifications. DFSS aims to design products or processes that are inherently defect-free and capable of meeting customer requirements and expectations, thereby reducing the need for subsequent process improvement efforts. So these are some of the main or top questions that might be asked in your next Six Sigma interview questions. Now, apart from these, you might be asked some generic questions as well. So let us discuss them, what they are. Now, you might be asked this question, which is how can you ensure the sustainability of Six Sigma improvements? Now, ensuring sustainability of Six Sigma improvements requires ongoing monitoring, standardization of improved processes, effective training, engagement of stakeholders, and a continuous culture of improvement. Well, now to sustain Six Sigma improvements, it is essential to establish controls and monitoring systems to track process performance over time. This allows organizations to detect any deviations or issues and take corrective actions promptly. Engaging stakeholders at all levels of organization and creating a culture of continuous improvement encourages ongoing participation and ownership of the process. Regular reviews and audits can easily help identify opportunities for further improvements and ensure that the gains achieved through Six Sigma are maintained in the long run. Moving ahead, the next question will be, what are the benefits of implementing Six Sigma in an organization? Now, the interviewer wants to know whether you have a perfect clarity or whether you understand Six Sigma and how you are implementing in a real life for an organization or for their company. So you can say like this. Now, the benefits of implementing Six Sigma in organizations are numerous. It helps in improving the quality of products or services by reducing defects and variability. Now, this in turn leads to increased customer satisfaction and loyalty. By analyzing and optimizing processes, Six Sigma helps in enhancing process efficiency, reducing cycle times, and increasing productivity. Now, improved process performance results in cost savings, waste reduction, and higher profitability. And additionally, Six Sigma fosters a culture of continuous improvement, teamwork, and data-driven decision making, which can drive innovation, employment engagement, and overall organization success. So the next question is, how would you prioritize improvement opportunities in a Six Sigma project? Well, the interviewer wants to know that now that you have a clear understanding of what Six Sigma is and how you are implementing into the project, well, he wants to further know how can you further optimize improvement opportunities in a Six Sigma project. So you can answer him in this way. Now, when prioritizing improvement opportunities in a Six Sigma project, it is important to consider multiple factors. Now, the impact on customers should be a primary consideration as it aligns with the organization's focus on meeting customer needs and expectations. Evaluating the potential cost savings or financial benefits associated with the improvement opportunity is also very crucial. Assessing the process risk or the likelihood of it and the impact of failures can help prioritize areas that pose the highest risk to the business. And finally, consider the feasibility of implementing the improvements, including resource availability, timeline, complexity, in order to ensure that selected opportunities can be successfully executed. So these were some of the main generic Six Sigma interview questions that might be asked apart from the technical questions.
So here we wrap up Six Sigma crash course. If you have any queries, feel free to post them in the comment section and our experts will be happy to help. Thanks for watching.
If you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.